Okay, good morning, everyone. Welcome. Good morning, DevOps, I guess. It's the first session of the week. Yeah, let's give it a round of applause. And you at least in part applaud yourself. I'm really pleased that you came out on a Monday morning. My main task these next couple of hours will to not make you regret that you got up at Monday morning to come here. We're going to talk about all the cool Java features that are new after 21. So that's the frame we're going to look at here. And before we start out, we could do some morning exercise. I was thinking about asking you to actually stand up, but I'm not gonna. I know nobody wants to. But what I want to know is, I want to know what Java versions are in use, right? I usually do this somewhere throughout the talk, but why not do it in the beginning? So I'm going to ask a very loaded question. I'm going to ask, what's the newest Java version your team runs in production? Right? Not your whole organization, just you and your team. So if you have all the way from 6 to 21, only raise your hand on the good version, okay? Good. So who here runs in production as the newest version, something before Java 8? For the people watching at home, that's, I think, one person. Good. What about 8? Okay, that's usually the big one, but I see less than 10%. So that's pretty great. Then I'm going to go to the versions that have long-term support by various distributors. So 11 is the next one, I guess. Okay, 10, 15 maybe %. And 17? Yeah, that's a big chunk. That's like at least half. 21. That's the rest, like what, 30% or something. That's great. Anybody running 22, now 23 in production? Yes. Also one person. That's good. Okay. So what we're going to do today is we're going to talk about all these Java things. I'm going to show you the split later. We're also going to take a break in the middle of the session. Not maybe necessarily exactly in the middle. Maybe we are lucky and we don't align with all the other long sessions, so you have, the coffee stations to yourself. I'm going to take at least 20 minutes so everybody has time to file out and file back in. So, there will be a break later. Okay, now let's start. As I mentioned, this session will focus on Java 22 and 23. If you do want to follow along on the slides on your device, you can do that. They work somewhat well on mobile, a little bit better on a big screen though. If you have any questions, please feel free to just raise your hand, and then if I don't see you after 10 seconds, just yell. Just interrupt me. I'm not taking a lot of pauses. I'm not really known to breathe while I talk, so just yell when you have a question and I'll get to it. This is what's been finalized after 21. Unnamed Patterns, the foreign function memory API, multi-source file programs, which I'll embed into a larger discussion about launching Java programs, Markdown and JavaDoc, and then generational ZGC. And we're going to go through all that, and once we're done with that, we're going to take the aforementioned break. And after that, we're going to pick and choose as many of these topics as we can. So these are preview features that are currently ongoing. These are not all the preview features, but the ones that I found most interesting and thus have on slides. And if we don't get through all of them, I guess that's fine too. So let's see how much of that we can get done. And with all of that out of the way, let's just get started. Let's talk a little bit about unnamed patterns. So what are unnamed patterns? If I would just have 45 minutes to go through all of these features, this would be the only slide I would show you on that topic. That's basically the underscore. You can use the underscore to mark unused variables wherever you will encounter them. It also works in try with resources blocks, for example, although use cases are rare. Even works with method returns, and the use cases are even rarer. Where you most often see them is within a Lambda. You've probably all written Lambdas where you don't need all of the arguments that the interface can give you. So now you don't have to decide, do you want to call it unused, or what do you want to do there? You just give it a single underscore, and it works. You can do when you do an instance of check like here and do a type pattern, a record pattern match there, and you take apart the user record into its components, and you only need the one. You can ignore the other one, and then we have the last one, which is arguably the biggest one. If you switch over, in this case, some kind of object, and you do the type patterns, and you say, well, I do want to know whether it is a user, because you don't want to increase the user count, but I don't care about the variable itself. You don't have to give it a name. You can give it an underscore. And you can also have several underscores in a single scope, by the way, so that's all good. Now, as I said, we could leave it here, but that last point is really important, and I really want to drive home how important it is by walking you through an example that also recaps a little bit of pattern matching and how to use it. And so we'll take a little bit of a detour, and then in a couple of minutes, we're going to get back to why this underscore is important here. Okay, so let's assume we're making some simple application. This is a GitHub scraper that you give it a GitHub URL, and then it just connects to that URL, finds the page. What is it? Is it a commit page or is it an issue page? And it scrapes all the content, it ignores the header and footer, and then sees what links are there. What other links are you, as a discussion on this issue, linking to? Other GitHub issues, but could also be external pages like Wikipedia. Of course, things might fail, so there could be error pages. And then it takes all the GitHub pages and pours it back into the same process, and then you probably want to cut it off at some point, so you download all of GitHub. But yeah, so that's the idea here, right? So we're scraping GitHub, and then we could build a bunch of features of that, right? We could have these page instances that I showed you here. So we have this page type, and then we have these subtypes. And then we have all the kind of functionality building on that. We could display this as an interactive graph. We could compute some graph properties. Maybe we want to categorize or do mood analysis. And if we do all of this and offer it as a service, maybe we want to have payment, etc. So there's a lot of features, is what I'm getting at, building on these few core types. Now, how could we implement that? The most straightforward way to do this would be to put all of those methods on page. But that is terrible, because now you have a type that knows the payment subsystem, and it knows like some canvas to draw itself on, and it knows about mood analysis. And that's clearly a bad idea, that all these clearly very different and non-trivial subsystems collide on the same type. So we really want to get the functionality out of those types. And then the object-oriented approach to that is the visitor pattern, which is the best solution, and if you need it, you really should use it, but it's also not exactly known for its elegance and ease of understanding. So that's not great. So the way forward that you can do this in Java is with pattern matching. And so let's talk through what that solution would look like. This is all the ingredients we need. You see unnamed patterns there at the bottom. We're going to get there. These are links to the JDK enhancement proposals that finalize these features. They go into details on the motivation. If you ever wonder why do seal types look the way they look, or why do type pattern matchings do this thing this way and not that way, the JEPs are always a great place to get those kinds of information. And so we're going to use all of these now to implement these features. The approach is to make the page interface sealed, and then we're going to implement all our features as methods outside of that interface. So somewhere there's a payment system or categorization system that gets a page, and then it switches over that page. And then we need to avoid the default branch for maintainability. And again, this is where the underscore comes in. This is where what we're going to drill into the most. So this is how we use a sealed page. We create a sealed interface. You can see that my code highlighter doesn't yet know that sealed is a keyword since, I don't know, what, 2 years now? So that's not great. And so we're sealing the interface page, and then we're listing which types can extend or can implement it. That means no other type can do that. If any other type says, I implement or extend page, they will get a compile error. So that doesn't work. That communicates to ourselves in the future, to our colleagues, but most importantly, the compiler. These are all the subtypes that page can have. And there are a few rules that they have to obey by that we're going to skirt around here, because that's not our focus. But if you do this kind of stuff, you've probably, if you're on 21, you've surely used this, and on 17, you can already see like the first parts of this. This is what then the switch would look like. So I'm getting, as I said, this categorize method lives outside of page. So it gets the page as an input. And then it needs to figure out what type is it, what kind of page is it. So the idea here is that categorizing issue is a whole different logic than categorizing a pull request. That's why I have specific methods to categorize specific kinds of pages. And what I need to do here essentially it's just I need to do a dynamic dispatch. I need to figure out what type do I actually want to, what methods do I actually want to call for this type. Right, so I hope that you can all read this with the switch extensions that have been added in 16, then I think, or 14 even already. That should be pretty readable for most of you. So I'm switching over the page and I'm saying, well, if it's a GitHub issue page, give me a new variable of that name, and then execute that method with that thing. Okay, so that's all good. That works, that compiles, that's fine. Now let's start going towards default behavior. Because sometimes you have that, right? Sometimes you're in a situation where you do not actually want to treat each individual subtype. Sometimes you have an interface that you implement, and the implementation is an empty method. Or has like a very simple default method. In this case, that would be, we need basically an empty branch, kinda. We have the situation where we only want to categorize the GitHub pages, and the other two pages, the external pages and the error pages, we don't. So we just want to return none for them somehow. So how do we handle the remaining cases? So first of all, this would not compile for kind of obvious reasons, because if we have a GitHub error page, then none of the branches apply. So what could the switch even return? And if you say null, we're going to have a serious discussion later. So this would be a compile error already. And even without the return, though, even if you don't have to compute a value, it is also a compile error on with these more complex switches, which is good. So because unlike an if-else-if chain, which says if it's this type, do this, else if it's that type, do that, a switch needs to be exhaustive. It needs to cover all cases. The compiler forbids writing an expression or a switch statement that uses patterns that do not cover all cases. Now, how do you cover all cases? Use a default branch, or you actually explicitly list all the pages, all the types. So let's go with option 1 for now. Let's have a default branch here. So this works. This compiles, this is fine. GitHub issue page and pull request page get categorized. Every other page doesn't. They get category none. And that seems to be all good. And that's all good until you add a third kind of GitHub page. The project manager came back to us Friday morning. OK, so we found out GitHub has more pages. You need to implement this by Friday afternoon. So you're hardly going through the code base, adding GitHub commit page. And this switch will still keep working. It will still compile, it will still run, it will just unfortunately do the wrong thing, because now you fall into this default branch. So what happened here is that we added a new implementation of this interface, and if we had an actual interface that we're implementing and all the methods, or the categorized methods would be there, we would be forced to implement it. We would face the situation where, oh, how do we implement this method? But here, this way we don't. So we create this new type, and then the type just always falls into the default branch. And that the compiler is happy, runtime is happy, but we don't get the results we want. And of course, this is tested, so we found out before we put it in production. But hypothetically, let's say you want to get this error earlier. So this is the way you would do it in 21. If you don't use preview features, that is. You would have to put those two explicit branches at the bottom. So if you have an error page and an external page, you return category none. This is all nice. We have duplication, so that's not great, but it works. If you now add the fifth type, because this one is exhaustive, right? If you only have these 4 subtypes, it works, it's exhaustive. Now, if you add the fifth subtype, it's no longer exhaustive. And accordingly, you get a compile error. And that is good, right? That's what you expect. You added a type, and one of the operations that said, I'm going to handle all those types, doesn't. And so you get a compile error, and the compiler forces you to face this problem and fix it. So that's nice. But let's talk about the duplication. Because this would be nicer, right? It would be nice to say, well, the error page and the external page really have the same behavior. I don't want to repeat that. And for 2 branches, it's kind of OK-ish. But if you have like 3, 4, 5, it really gets annoying. So it would be nice to combine those. But that doesn't make sense. That compiler doesn't allow this. And the reason for that is that if you have something like the first branch, case GitHub issue page is, if you're on the right-hand side, you can use the variable is because the compiler knows, well, apparently it has been issue page, right? So that's why you can use the variable. It's in scope because the test was true. But on the right-hand side, or in this case, because of the line break, on the lower side of this of the last branch, case error page or case external page, which one is it? I don't know. Either of the two. That means we could use neither of the 2 variables because either one could not be the right one. So that would be really weird that we have this there and then it doesn't work. And now you can probably see where the underscore comes in, because this makes sense. You can now say, well, if it's an error page or an external page, I don't care about the variable. And if you don't care about the variable, there's no conflict, there's no ambiguity there. It's all good, and you can just write your branch. And this is why this is important. This is where the underscore shines the most. Yes, it's nice that we no longer have to write out the name unused for a variable that we don't use. But this is much more important, because this is something that changes how you program. And if you are on 21 and you are using these pattern switches, please use this variant, because otherwise you're going to run into trouble. You're not going to get the maintainability that you want out of pattern matching. And if you're courageous enough to use preview features, you can already do this. And otherwise, if you're on 22 or 23, when you update, or for many of you, probably 25, you can use these branches. You can use the underscore to combine these branches. And that's why this is really important. If you want to read up more on that, every section ends with a few more links if you want to dig deeper. Always the JDK enhancement proposal is like a great way to start. But if you don't want to read for like 30 minutes, we usually do some videos. This one's actually almost also 30 minutes, so that's not really a shortcut. But it does more. It basically goes through the same example in much more length and depth. And you can also see a little bit of my living room if you want to. OK, that was the first one. Did you have any questions about that? Yes? So the question is it lazy loading? It used to be eager loading before. What exactly do you mean? Like, do you mean like the right-hand side of the branch was executed? Oh, you mean like in the very first slide? So let's see. So you said that somewhere up here? So what's computed? Yeah. Yeah. Oh, you mean the accessor? So okay, so to repeat for everybody where you didn't quite catch it. So what I'm doing there is I'm using a record pattern to take apart the record into its components. And the cool thing why this is possible is because a record says very publicly, this is my public API, all my components are publicly available, and they have accessor methods for that. This is not some evil injection, I'm gonna go deep into your type. This just calls name. And so the question now is the second one also called? And you wouldn't believe it who I have here in the audience. Angelos who developed this feature, and he's shaking his head. So it's not. That's good. Okay, so apparently the second accessor will not be called. That's good. Thank you, Angelos. Because I wouldn't have known. I didn't even notice I did that in the past. Yes?
About the last example.
Yeah?
If you have an interface, let's say, uncategorized, the last example.
I mean like on the very end of the slides?
The last one, yeah.
Yeah.
If you have an interface that is called, let's say, uncategorized pages, and you
Yeah.
have those two types to implement it, and you put the case there, then it will cover,
Yeah. Right, so the question is, if we have like, basically Mario is asking if the type hierarchy is not as trivial as I showed you. What we did now is we had a page super type, and then we had like 4 implementing types. And there's like, if you want to switch over the first one, you have to list all the 4 ones. What if you have something more interesting? So for example, what you could do is you could have a top level type page that permits GitHub pages and, I don't know, non-GitHub pages or whatever. And then the GitHub pages are like 3 types, also sealed, all of that is sealed, and the other ones are the other ones. Yes, and you're right, like you can do these intermediate steps. So you can say, okay, I'm switching over the top level type, and then I'm saying, in case it's a GitHub page, I do maybe a nested switch even, and that forces me to be complete. And on the top level, I say, if it's not a GitHub page, I just have like the one branch for this other case. So yeah, so if you do have a more complicated type hierarchy, as long as you somehow exhaust all the options, the compiler will be fine. One thing you can actually always do that is, there's actually a third option to do this, but it's basically the default option. You can always just write, let's say here, the laser pointer actually works, surprise. So instead of default, you can write case page. So you switch over a page and you say, well, if it is indeed a page, which it is guaranteed to be, you will execute the last branch. So you can put all types and subtypes in there, and the compiler will verify whether it's exhaustive or not. Okay, more questions? Good. Let's go to foreign function memory API. Now, not sure what that says about me, but when I started learning programming, I did this with Turbo Pascal and then later Java. I never went the C and C++ route. Being a big Linux fanboy, I really felt like I should learn that at some point. So, because then maybe I can even contribute and I can do more things on my own operating system. And so one weekend I cleared the weekend, and Saturday morning I started learning. I was like, okay, I'm going to do some tutorials, C, C++. I'm going to get into that over the next couple of weeks and months. After 4 hours, I basically did the table flip and decided to not do that at all. Never, ever am I going to touch that language. If I'm going to learn a new language, I'm going to pick one that makes my life easier, not harder, and gives me more foot guns. So that means nothing. Then I want to bash C and C++. That's all good. But what I'm saying here, this is not my forte, right? So I'm going to talk a little bit about foreign functions, which means C code and how to call into that. But this is very much the one-eyed leading the blind. So please, if you do this already, if you're interested in this, totally look into this. We're going to stay a little bit at the surface level here. The blind meaning if you don't know C and C++ like I do. If you do know, you probably know more about this than I do. Okay, good. So FFM means Foreign Function and Memory API. So that's like a two-part API. And we're going to start with the first part, which is foreign memory. So foreign memory means you want to control the memory outside of the heap for whatever reason. A big reason is that you want to memory map files. But there are tons of other reasons. Maybe you want to create some weird data structure that you can clean up better than the garbage collector. Or maybe you want to share this memory with native code. There's other motivations to do this. But it's not really common for most of us. There are 2 ways to do this. One of them is the byte buffer, but that's limited to 2 gigabytes, which nowadays is not a lot. And it's kind of inefficient. And then you can use unsafe, which is, unsurprisingly, unsafe. And in a discussion yesterday with my colleague Jose, we found out it's kind of unsafe in 2 ways. So unsafe not only lets you write code that can just crash the JVM, but it's also unsafe in the sense that it can change and evolve over time. We'll actually see that later. And that means that you cannot rely on it staying the same. It's unsafe in terms of maintainability. But that's always bad. It's always bad if you have two options and they're bad for different reasons, and then you have to pick one of those. That's always frustrating. So the idea behind the foreign memory API is to overcome this and say, okay, let's introduce an API that is safe, but that is also as fast, or at least almost as fast as unsafe, so everybody's happy with that. It allows you to do something that is very uncommon in Java. It allows you to do explicit deallocation. So that's something that usually is not the case. That's actually one of the problems with byte buffer, that the byte buffer might reserve 2 GB of memory, and then those 2 GB are freed up when the byte buffer is freed up. When does that happen? Well, nobody knows, when the garbage collector gets around to it, which is not great, right? So that might mean you might block like a decent amount of your memory just because the GC didn't collect this like tiny little byte buffer object that blocks like 2 GB of heap. So you have more control over that, specifically mostly with the arena, and then you can get memory segments and allocate those. And then if you want to access and manipulate that, you use memory layout and var handle. So this is what the use of the foreign memory API often looks like, specifically together with the foreign function API. So we're going to go through this example, and we're going to expand it. We're never going to see the whole one because it's a lot of code that never fits on a slide. But basically what we're doing is we're saying, okay, we want to get some off-heap memory. And then what you usually do is you allocate some stuff, and you push the stuff over there from your heap. And then potentially, which is what we're going to do here, you run some C code on this. And then later, get all the data back into your heap. And then you keep going. And if you use an arena like this in the try with resources block, when the try with resources block ends, that's where the memory is deallocated. So you guaranteed that however much you allocated, when this code is done, it's going to be freed up again. So how do you allocate off-heap memory? Here I'm having an array of Java strings. And then, and I'm not going to go into the details, you need to do some jumping through hoops, right? You need to allocate an array. You need to start with an address and how much do I need. And then later, when you're down at the memory segment, you start to allocate something. And you need to know what you're allocating, right? The UTF-8 string encoding of cat looks different than an ASCII encoding, for example. Well, actually, no. For UTF-8, that would be the same. But yeah, you could go UTF-16, for example, if you have non-ASCII characters in there. So you do this loop to go through the array and stuff everything into this off-heap memory. And then comes the step which calls the foreign code, but we're going to do that when we come to that part of the API. When you're done with your whatever you want to do with the off-heap stuff, you're going to copy it back. And this then is similar to the code before in reverse. You find the right memory address, and then you tell the Java API, interpret that, what you find here, as a JDK, as a UTF-8 string, and give it back to me, and then you get a string object back. Okay, so that's the part about foreign memory. Foreign functions. Foreign functions mean non-Java code. That is mostly, at the moment, that I think it's just C that works at the moment, but this is set up to work with other languages as well. And I think actually, so first of all, Jose, I think, has something on the foreign function API while he's here, and I think Anna's also talking about doing this in Python, if I remember correctly. So there, if you're interested in this, do check the schedule. There are talks that dive much deeper in this. So if you want to call code that is not Java code, in the past you'd use the Java native interface, JNI, for that, and that wasn't great, is what I hear. People have not been having a lot of fun with that. There's tedious artifacts involved. You need header files and implementation files. The toolchains are not ideal, and the type systems are quite different. They don't get reconciled. So it's a lot of extra things you have to fix. And this is actually a problem when you think about high-performance stuff that is written in C and C++. For example, nowadays, machine learning and AI libraries. This is a big challenge for Java. It used to be a big challenge for Java, because the reason why Python is used in that space, or one of the reasons why Python is so much used in that space, is that Python just makes it easier to do this. And that's important if for example, Google develops TensorFlow in, I think, C++, not entirely sure, then what you don't want to write C++ code, so you want to write code in a more high-level language. And if that high-level language, but then makes it really hard to call into the library, then you don't, right? And that makes it harder for Java projects to track these fast-moving targets. Something similar as if you do game development, there are like gaming engines that are wrapped into Java. And so these projects, wrapping these existing non-Java, these native libraries into Java code, have a hard time tracking that because it's a lot of effort. And the foreign function API that is now introduced does a much better job at that. So the idea here is that method handles are used for the calls into the native library. And writing that code that does the method handle invocations is kind of cumbersome, but it's fully automatable. That's what JExtract does. So JExtract, you point it at a file, and it just says, OK, I'm going to create a Java file that uses method handles for all of these calls. So that's good. and then you would write your Java API on top of that. And if the native library changes, you rerun JExtract, you get a changed adapter layer basically in Java, and then you can update your code if anything changed when it comes to the API. Okay, and also you'll see here that we have additional types that are involved to call foreign functions, and this is what this inner block, what this would look like in the example that we just started. At first, at the top there, we have to create a linker, and we have to create a symbol lookup that we get from the standard lib here. So this is basically telling my operating system, just give me the regular standard lib that's lying around there. And now please find the radix sort method. That's what we're looking for. So apparently in my standard lib on my system, there would be a radix sort method, and we're going to get this method handle that does this down call. So I'm not using JExtract here, by the way. This is basically the thing doing it on foot. And then we have the code blocks that we just saw. We have this Java array, we create some off-heap memory, we put all the stuff off-heap, and then we say radix sort invoke, we point at the array, we tell how long it is, and a few more pieces of information. And then the foreign code runs on the foreign memory. And once that call returns, we're going to copy everything back as we said before. Of course, this is ridiculous, right? We have a sort method in Java. But you see I would use this for functionality that might not exist in Java. Okay, so this is how FFM APIs work on a high level. The important news here is that since 22, those are both final. So they have been in preview for first incubation, then preview for quite a long time. And they were kind of almost getting finalized in JDK 21, but then not quite because there were some more minor changes being added in 21. And so the people behind Project Panama thought it would be good to give it another round of reviews. And that's why it's finalized in JDK 22. This, by the way, also dispels the myth that features are rushed into LTS versions. So OpenJDK, who does this, doesn't consider 21 any different from 22, at least not while they're developing it. And that's clearly not the case. If this would have been rushed into the next LTS version, then this would have been 21. But that's not the case. So this is it just comes down to how mature is this? Are we confident that this is now in its best and final state? And if no, it gets another round of review, no matter how long this specific branch might be maintained in the future. Okay, so you get user-friendly and performant mapping from native memory to Java records and interfaces. There will be more features added to make, for example, to map records, or in the future probably value records with Valhalla, to map them to structs. So to make it easier to do this translation layer, to give that more intelligence, so you have to do less work yourself. And there's also work going on in improving JExtract and the surrounding tooling, and there's even more going on. So while Project Panama delivered its biggest chunk with the foreign function memory API, it is by no means done. So these features do still get improvements and are getting polished. Again, the JEP is the best source to get started if you want to look deeper into this. There's a great talk by Maurizio Cimodamoro, who was leading this, and the Project Panama mailing list is a great place to report back any things you find missing or any challenges you still have. And this way you can support the future development of the JDK just by trying things out and letting those folks know what could still be improved. I'm a little bit afraid to ask if you have questions, because as I stated quite clearly throughout this, I'm not sure whether I can answer them, but do you have questions? Thank you, you're very kind. Okay, let's keep going. We're now going to launch multi-file programs. Okay, so when we're thinking about sitting at a conference like this, we realize that this is actually quite a mature, and I try to avoid the word complex, but let's say a mature and intricate ecosystem that we're working, right? Java is a very refined program model. We have a very detailed tool chain with something like JavaC that just does the one thing, and then the jar tool, and then JPackage, and so that's all there. And then we also have build tools building on top of that. We don't just have one. We have at least 3 very mature build systems in the community. We have various kinds of IDEs, various kinds of distributors for these JDKs. We have basically for everything that you would want under the sun, Java has many options for you, which is kind of cool for us developers. But it's not that great for somebody starting new, right? If you ever wanted to show maybe to your kids or to students or to the front-end developer who's done JavaScript a long time, and they ask you, okay, so I download Node here. Where do I download JDK? And you're like, oh, well, that's actually a complicated question. You can see how this maturity, this choice that we all have and that we mostly enjoy in our careers or in our work, makes it hard for people who enter the ecosystem. And that's not great. It would be kind of nice for new developers to have a more straightforward on-ramp where they can start things a little bit simpler. And so this is what mostly Project Amber is building right now. I just touched on a lot of things, like how there are many IDEs and many build tools, and these 3 points are not tackling all of that, right? They're actually just starting at the program model. They're trying to limit, and a little bit at the tool chain. They're trying to limit the amount of programming and tool chain you need to know up front. So they're just tackling parts of the problem. There are still many parts that are left unsolved, but they will maybe get tackled later. And also, it's not just something that OpenJDK needs to do. It's also something the community can contribute by giving more clear guides, for example. But that's a different topic. Let's stick to this. This is something that the OpenJDK does already: simplified main methods and classes, single source file execution, and then multi-source file execution. So the first one, simpler code, means removing all kinds of stuff from the first piece of code you write. You don't need arguments if you don't actually pass arguments. Why does main have to be static if you just have the one instance of it? Why does it have to be public if you just have one class? Why would you have visibility involved? And speaking about the class, why even have that one, since you're only writing a method? And so in preview in 23, this is the smallest viable main.java file. This is not a part of the file. This is the full file. You can put this into a Java file and then just tell Java to launch it, and it will work, and that's fine. So that's really good. And that means then from there on out, you can add these things back in. That means if you have explained this to a beginner, or even just a Java beginner, you don't have to explain to them a bunch of concepts that they don't need right now, and you also don't need to tell them to ignore them, because I think that's almost as bad. If somebody is learning and they're curious and they're pointing at static and asking you, what is that? And you're like, let's not talk about that now. That's not good, right? Because you're basically telling these people that there's like magic involved that they should not supposed to look into now. So I think this is much better because it's much simpler. A step beyond that, that's also in preview in 23, is that instead of system out print line, which people have made fun of us for like 2 decades now, we can get, we have a new type which is called Java IO. It has just print line, and read line. And read line is, here's a prompt, display the prompt, and then when the user enters something and hits enter, give me back the string. So it's just a method that takes a string and returns a string. Super easy to use. And now we get those methods imported by default. And we get also all top-level classes in Java base imported. I will talk to you later about how that works in detail. But for now, that means this complete main.java file there uses list, the list interface, without having to import it, and uses print line without putting system.out before it, which is, I know, not exactly revolutionary, but it's still nice that Java does this now. And I've been using this since it has been started as a preview, I think in 21. So much. Like I always have a main.java file around now where I just like, whenever I write slides, something, just paste code in. Oh yeah, that works. Take it back out. It's really so cool to experiment with. That is, in the past I always had an IDE open for that. And now I just have a text editor and type it in there. And now you've typed your code, what you do with it. Since JDK 11, you can actually just throw it at the launcher. You don't need to Java C and jar and whatever. You just tell Java, here's a single source file, and it will compile it in memory and then run it from memory. And what is new in 22, which is why this whole section is part of the finalized features in 22 and 23 part, is this. So you can now have a more complex program, like here I have a main class and a helper class, and I even have a library. Although it's quite a question, like, where did I get that? Because apparently I'm not using build tools, so how do we get the jar? Let's not go there. But let's say you have a jar from somewhere. Now you can just launch this as well. You just give the Java launcher the main class, and then it will find out, okay, so the main class is in that folder, so we'll make that the source's root, so it references another file. I can just expect to find the file in that folder, so it does some smart things, and it mostly just works. It also works if you have like the source main Java tree, for example, and you launch the file and you say Java launch source main Java, and then you can even have packages if you want, /main Java. It will figure things out. It will look at the package declaration in the file, and will then basically use that to navigate to the source's root of that folder. It does a really good job at figuring this out. So it mostly just works with all the typical layouts that we use. And this, like I said before, also something I'm doing constantly if I have like something more involved that I want to try out. Again, instead of just setting up a real project and then maybe considering should I already set up Maven now or maybe later, I just don't. I just dump like a second Java file and start coding in that. So that's really cool. And that gives us a very natural progression now. We can start with just main in its own file, and we get started there. And then the question is, what does the newbie, the beginner, the learner, or even ourselves, when we experiment with this, what do we need next? If we need arguments to pass in something from command line, you add the string array. If you need to organize your code, you can already add methods, right? So you don't just have the main there, you can have different methods in there. If you need to share state, you can even add fields. We still don't have the class wrapper. We basically have just top-level fields in that file, so that's fine. We can explore the JDK APIs without having to know which package they come from and having to import them, as long as they live in Java base, that is, which is very straightforward. Like that's, well, maybe it's not obvious what is in there, but there's a lot in there is what I'm saying. Like most simple experiments don't need much out of the base module. If you get the libraries from somewhere, you can use them very simply as well. If you need more structures, you can start splitting this into multiple files. You can use visibility and packages even with the multi-source file launcher. And the cool thing about this, it doesn't even have to be this order, right? Most of those things are like you can pick and choose what you need. And this way you can have a simple project for a simple use case. And only once you start to really get into like a large-ish project where you go like into several packages, that's like the latest probably where I would start using like a proper setup, or where you want to ship something, where you do want to package a jar and hand it off to somebody else. This is where you would start then figuring out, okay, so how does Java-C work? How does jar work? More likely, which build tool am I going to start using now? But that means all the way up until you want to ship code and you stay within a somewhat simple project, you can just keep going like this. And I think that's really cool because that really means that there's just the entry is simpler and you don't need to tell beginners basically the first thing you do, well, just install IntelliJ Eclipse, which is for most people the most complex app they've ever installed, right? So that's good. I really like those developments. If you want to learn more about this, these are several different JEPs, and then there's also several videos that we made on all of those, and you can totally check those out. Do you have questions on this? I'm now back to answering them, so just in case. Why do we need void before the main? Right. So the question is, some people even ask, why do we need main? Right? Why don't we just top-level statements? The idea here is that as you go from starting with main all the way down here, you never have to unlearn anything. You never have to, oh, that's something that doesn't work in this new context. And so the thing is that for that, statements within a method and statements outside of method local variable declarations specifically have slightly different scoping than fields would have. So the idea is, instead of having method local declarations and then not have a method frame on the outside, we want to have a method as the atomic part. That's like the smallest unit that you have to create. You have to create methods. And then let's create full methods, because nowhere in Java can just leave out the return type. You can leave out visibility elsewhere, right? But the return type, you always need the return type elsewhere as well. So let's write methods in a way that they look like actual methods will look later. So that's the reason why the void is still in there. But yeah, the void you still have to either hand wave or explain. True. Okay. Yes? Okay, so the question is, will this get further advanced or development in the future, or is this what it is? Well, first of all, some of this is still in preview in 23. So the simplified main, for example, is still a preview. I really hope it stops being that sometime soon. So in that sense, it's definitely still in development. But this is also part of the larger on-ramp efforts. But these, I think, on the language level, I think this is about it. It's my guess. Like I can't speak for the members of Project Amber who developed this. There is gonna be an Ask Me Anything with the Java architects. Ask the Architects is what it's called. I think it's on Wednesday or Thursday, where we have all of those people sitting maybe right here, and you can ask that very good question there. I know that there are further things that are being considered, but it's not for me to share those. So maybe you can get it out of Brian, for example, and maybe you can go into a little bit more what other things are being explored or maybe already even worked on. Okay, let's talk about Markdown and JavaDoc. Okay, I have a question. Last week, who wrote some code last week? Okay, keep your hands up. Keep your hands up. Now, lower them if you did not write JavaDoc last week. Oof, that's rough. That's like, I don't know, 60% of the people just like, nah, comments, we don't need those, right? Okay, so I actually have an issue with that. I think you should probably write JavaDoc, although I don't know what specific project you're working on, so who knows. Oh, maybe, all right, maybe it hasn't been Java code, right? I should have asked whether you wrote Java code. Okay, good. Let's just say all of those people were not writing Java, that's why they couldn't write JavaDoc. Okay, so JavaDoc, I think writing JavaDocs, I can give you my philosophy on this. I think a well-documented code base needs at least like a couple sentence explanation on each type. At least that, even non-public types, even just for internal. I know that, comments age and there's all discussion to be had there, and I'm gladly having that any chance you give me. But the basic abstraction of a type is probably not going to change from week to week, so at least put that there so that people know what, I don't know, one of those random types you have in your code base, what they actually do. And what I did in the past, when I had discussions about this with my team, who were like, well, not my team, I was a member of a team, and one of the younger ones too, so nobody listened to me, which was probably a good idea anyway. And they were like, no, we don't need, we have self-documenting code and everything, and I really think we didn't. So I asked them, okay, let's do this. In Eclipse, when you type, in IntelliJ as well, I guess, when you type the capital letters, like if you have the open type dialog and just type capital letters, it finds the type that, that fits those letters, right? So if you have people in your team who say like, no, our code is self-documenting, you just look at the code, you'll figure out what the types do this. Open the open type dialog, just type random letters until there's just a few types left, pick one of those at random, give them 30 seconds to look at it, and then ask them to give you like a good summary of what the type does. Bonus points if you find interfaces with like 2, 3, 5, maybe 10 implementations, they're not going to be able to. And those, I think, need JavaDoc. Okay, so that's my spiel on why people should write more comments, me included. So I think JavaDoc is great, but writing complex documentation, when you have more than a paragraph, gets cumbersome really fast. So first of all, I always forget where to put the opening and closing paragraph tags. Oh, that's minor. Then again, my IDE keeps yelling at me when I don't do it right, so there's that. But code snippets and code blocks are really terrible, specifically code blocks. Lists are verbose, and tables are also terrible, and the list goes on. So like writing JavaDoc, complex JavaDoc is not great. And the reason for that is not JavaDoc, the reason for that is HTML, really, because HTML is a great markup language, but it's not one that is really comfortable to write. And then specifically not if you do it like within a different file format, within a comment format. So that's not cool. Markdown, on the other hand, is much more pleasant to write. No paragraph tags, code snippets and code blocks, that's a big one. Super simple and straightforward. Lists are simple. Tables, still terrible, but less so, arguably. And you can, that's really, really good about about Markdown, you can just embed HTML. It just gets passed through as HTML, so whatever you want to do in Markdown that you can't, you can just use the HTML straight up, and that will work. But maybe most importantly, why it became maybe Markdown instead of something like AsciiDoc is, Markdown is just widely used and known. So you can really start with a leg up where basically every developer already knows Markdown because that's how they're, Slack and GitHub and everything, Confluence and Jira. How could I forget everybody's favorite issue tracker? All of those except some, well, Jira's hiding it, but it does still accept Markdown as far as I know. So, everybody knows how to use Markdown. That's really helpful, so that makes it easier for everybody to use this feature. But also Markdown on its own is really capable here. And that's why Java now allows it. This is final in JDK 23. So you can write Markdown comments by starting your line with 3 slashes. Every single line starts like that. You can use comment mark 0.30. I made the mistake to put on a slide 0.3 in the past because trailing zeros don't matter unless you use semantic versioning, but then they do. So 0.30. That's one of the most recent comment mark specs there. We'll talk about the links in detail, but just as a starting point, you can use this this reference links syntax to link to code elements and program elements. So if you don't know this syntax, the way it usually works is you write the text that you want to link in square brackets, and then you write in square brackets not the URL, those would be parentheses, right? You write like something like a 1 or a short string like the API-doc or something, and then at the bottom you put like a footnote. Again, in brackets, API-doc, : this is the actual link. That way you can reuse the same URL in several places without having to repeat it. It also makes the Markdown source a little bit more readable. This is why Markdown offers this feature. And what Java basically does, it says, okay, if you put in this as a link reference in the square brackets, something that is a program element, I will figure out which one that is. And I'm going to go into detail in that in a second. And you can use JavaDoc tags as usual. And now from the JEP, I brought this, which is actually readable now because the screen is huge, but you don't have to read it. This is the same kind of comment, once with a regular JavaDoc and once with the new Markdown-based JavaDoc comment. And if you just look it over, you can see that the text doesn't reflow, so it uses the same line, so there's not that much noise in the div. But you can see everything that changed on the right just got much simpler from what it was on the left, right? So you don't have to do the LE and the UL anymore. You just have a blank line and then some kind of enumeration character there. You can use backticks for code. For example, we can look at the link maybe of the hash map up there, which now is just Java util hash map in these square brackets. And it's just simpler. It's more comfortable to write. And so that's really good, I think. It's a nice little improvement there. Now we can go over some of the details. Specifically, one that's maybe often asked is why the three slashes? It's like we already have like the slash, asterisk, asterisk, and other languages like Markdown itself actually allows you to put 3 backticks as a code block, and then after that you just write. You mentioned the language, right? You say backtick, 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 Java or CSS, and then you get code highlighting for that. Wouldn't that be nice here? It's also more expandable in the future. Maybe we can have like an ASCII doc processor for this, and then you write just slash asterisk asterisk ASCII, and then you get ASCII doc in there. There's very good reasons why not. One of them is, and I did not know that actually, that the leading asterisk here in JavaDoc is optional. My IDE always puts it there, so I always thought like it has to be there, but it doesn't at all. Like these are just used by us out of habit to make the thing more readable, but they don't have to exist. So if the leading asterisk in JavaDoc doesn't have to exist, but the leading asterisk in Markdown means this is a list now, it becomes like this is not impossible to solve, but it's not comfortable to read. Like this leads to ambiguity where it's not clear anymore what's going on. But the more important reason is that one thing you want to put in your JavaDoc comments is code. And one thing that code might contain, ironically, is a comment. And this then would not work. So you have your Markdown block here. You have a fenced Java code block. And in that fenced Java code block, you want to write, in this case, an inline comment with like the closing asterisk slash. Or maybe you want to have a JavaDoc comment in your, because you want to demonstrate something about JavaDoc. That would not work because this immediately closes this comment. So that's the big reason. You could not embed all kinds of comments in this kind of comment. So that's why this setup doesn't work. We have to have something different. And if we have to have something different, then, well, what exactly and why? And 2 slashes already escape the whole parsing. It already tells the parser, stop caring, this is just a comment. And that's good, right? So it already escapes. So we don't need to make any further changes to the language. I would just add a 3rd slash, and then the JavaDoc tool needs to find those and process those. So that's why it became the 3 slashes. So, as I said before, you can use inline code with backticks, like here. You can use code blocks with fences if you want to, like this one. And if you write the language here, it will end up as a CSS class on that code block there. And then if you use some JavaScript library for front-end code highlighting, you can use that then to configure inside this Java tag. You have to look for this and that. And you can do that. JavaDoc has, and already like for a long time, maybe since the beginning, had an add script command line flag, which allows you to add JavaScripts to your website. So this just gets embedded as a script tag on the resulting page. And there, for example, you could then embed something like Prism.js to do the code highlighting for you in the front end. Let's talk about the links a little bit. I mentioned earlier that you can just use the brackets. And if you put into the brackets something that Java recognizes, it will just render that as a link. So you can quite see that here because my CSS says that being a piece of code is more important than being a link. That's why it's not. There we go. Okay, now you can see. Or you can there. Now we can see. Okay, it's a link actually, right? So I use a list here, and that got turned into a list. And then I say the module, and then in brackets I just mention the module name, and I need to close that with a slash because some modules are also package names. So that's how it knows that it's a module. And then it links that, right? So this is the resulting rendered output, basically, that I would get for that. And the same for string and everything else. So if you just link something like a method that you want to, in JavaDoc, link to a method down there, you just go with the hash and then the name of the method, for example. And then this one links to a method on a different type. And this works because string is imported, but if you have a list, you would have to write Java util list. And you can also use this whole setup to write more complicated links, where now I have just in the brackets, I have the program element to link to, and in the front here, I have the text that I want to show instead, right? So I want to say the Java base module, and then Java base. I kind of like setting modules because module names and package names do occasionally collide. I use module names only in italics and never as code. So, but I'm I think the only one doing it that way, unfortunately. So that way you can more easily distinguish them, and right, that way you get this kind of rendering. And also notice that if I use this syntax, this does not get rendered in code font, whereas if you use this variant, it's automatically code font. Which kind of makes sense, right? If you link to a specific type, you probably want to put that in code font. If you have like a whole phrase that you want to link, it stays. It's link plain is the JavaDoc tag here. Okay, tables, as I said, Markdown tables are slightly better than HTML tables, but I still don't like to create them manually. You can use something like tablesgenerator.com. Doesn't have to be that thing. I always type like live table generator, Markdown or HTML, and it basically gives you like a very simple Excel-like UI, and you just put your things in there, hit a generate button, you just get the Markdown table out. So that's what I do for creating these kind of tables, because doing that by hand, I always forget where the colons go and where the dashes go, and so I find that much easier. If you use advanced features that Markdown doesn't support, remember you can always go back to HTML, right? You can always use HTML tables to use all the HTML features and attributes that you need to use, for example, for accessibility. Just talked about tags. Java tags still work as expected. You can use them in your Markdown comments. If you have something in a code block that says add override, then JavaDoc is smart enough to understand I'm in a code block, so add override is not actually a JavaDoc tag, it's just a code in this case. And if these tags do contain text, then that's like input spec does, then that text is also here interpreted as Markdown in a Markdown comment, so that you can have Markdown there as well, as you would expect. So this all works. If you are on 23 and you want to dive deeper into this, JDK 467 is there for you. And my colleague Anna made a great YouTube video about that as well, where she goes over pretty much what I went over here, a little bit more detail here and there that you can look into. And yeah, then I hope that next time I ask, not 60% of you need to lower their hands, because maybe they did write a comment here or there. Okay, we're coming up to the last topic before the break. Yeah, we start at 9:30, right? No, maybe not, actually. Maybe I'll have something else for you. So we do this, and then we do something else, and we're going to take the break. This one is really short. Oh, I forgot to ask. Do you have questions about the JavaDoc parts?
What about the other way around? Running Java in a Markdown file?
What about the other way around? Running Java in a Markdown file. So I know for a fact, by the way, that IntelliJ kind of does that. So in IntelliJ, if you have a Markdown file and it contains code snippets, if it can figure out, it actually does that also with command line. With command line commands, which is kind of scary, but it just displays a little play button there, and then you can click it, and then it plays. But generally speaking, that's something that each tool needs to do, right? Like there's nothing that Java can do, because the GitHub renders Markdown differently than IntelliJ renders Markdown, which is different from what Jira does. So like everybody renders Markdown differently, so Java can already do something to make it easier for them to execute Java in Markdown. Oh, is that not what you asked? Okay. So I think I get it better now. So you say JBank does that, so you can test the Java code that you embed somewhere. So for that, you can in Java for a while already have code snippets that come from different files. So that's not part of this presentation, because that's been the case for since 21 at least. So what you can do there is you put your files, you put your code into a different file, and then you tell JavaDoc, take the lines 5 to 30, or take the lines between those tags and pull them into the JavaDoc here. And that's really big, because as you say, that way you can make sure that that code actually works. You can put this, which is what I would recommend to do this, the least you should do if you do this if you do use JavaDoc that way, to set up a separate source tree for just these kinds of files and have them part of your regular compiles, at least. So then you know they compile. And if you want to get one step further, you absolutely can. You can use this feature to have a separate demo source tree, just the one that I just recommended creating. It's the same tree, but there you can use a unit testing framework, for example, to say, okay, so this is the code I want to demonstrate, and then that's the challenging part. You have to extract everything that does the actual testing above and below, so that sets up the test and then verifies the result. And then you can actually have your code snippets be unit tested, which is like if you have a large project and you're doing a lot of that, that's really big. I made a video about that. My blog top is not online right now. Come to me later. I'll find that, and then you can that should work together with this as well. Yes, one more question. is there an easy way to transform the old JavaDoc to Markdown? I'm not aware. We have a talk about open rewrite, I think in parallel though right now, but maybe it's this afternoon. But you can totally do that. I'm not going to stop you, but I don't think like that mass transition really makes a lot of sense. Like it's a big change across a big code base, and you don't like reading original JavaDoc is not that terrible, right? Like it's still readable. So I would say I would not do that. I would say, right, if you want to use this, just write new comments that way. And when you fundamentally change an old comment, just take this opportunity. But also I want to guess that maybe something like your IDE can maybe do that on demand, right? I don't think IntelliJ does that at the moment, but they've been really good with these kinds of things to transform old versions of code at least into new variants of code. I'm not sure whether they're looking into that for this as well. But yeah, that would be something that maybe your IDE can do on demand. I wouldn't do like a big mass edit, but that might also be possible. So open rewrite maybe might be the right tool there, if they have a recipe for that. Okay, generational ZGC. Let's talk about that. So let's just talk about ZGC. Every garbage collector picks certain primary goals and then maybe secondary goals that they go for. And ZGC says lowest possible pulse times. Ideally, no pulses at all, and if they have to be like sub-milliseconds, no matter the heap size, that's what they're gunning for. And that's can be very important, right? If you have like a backend that always needs to be responsive, where you never want to have long pause times, like that's 99th percentile is really important to you, then ZGC is great for that. But you have to pay somewhere, right? None of this is free. So what you pay with here is with memory footprint and slightly higher CPU usage. That's compared to, for example, G1, which is the default garbage collector. And then even more that same direction is with parallel GC. That used to be the default garbage collector, right? In parallel GC, you're basically saying, I don't care about pause times. If you need to pause like 10 seconds to reorganize the heap, I'm fine. But what you get in exchange is the highest throughput and very low overhead. And G1 is kind of in the middle of those. And these are not the only, like this is not just a triangle between what throughput, memory, and CPU. There's like a multifaceted oploid with many different things you might want out of a garbage collector. But the big three, kind of like GGC and G1 and parallel GC, kind of give these three options. I don't care about pause times, max throughput and a little overhead. That's parallel GC for lightly batch jobs maybe. G1 sits in the middle, which is why it's the default. And then GGC goes the other way and says, low pause times, and specifically on huge heaps, is the thing we care about the most. And yes, you have to pay a little bit extra in memory and CPU usage. In JDK 21, ZGC became generational, meaning it uses the generational hypothesis, which is most objects die young, and those who don't die young usually grow very old. So it makes sense to basically have a space where all the young ones can be generated, and then you just take the few ones that survived out, handle them separately, and then the new ones, then you can just raise that block basically of the heap and reuse it for new instances. GCs, as I said, do this by tracing this young and old generation, and they all do this slightly differently. So it's not like this is like a one uniform switch that you can just flip. Every garbage collector has to make the different decisions here. GGC didn't do that in the past, but can do it already for a while. And there have been some really good results with that. Netflix specifically published a blog post about that on their adoption. It's linked here. I can only recommend to give that a read if those kinds of metrics are important to you. I'm showing you two out-of-context graphs, which is very dangerous. So please don't take away from this. Nikolai said this is great. I'm just going to use it. What I want to show you here is that this is worth investigating if you care about performance. So what we see here is memory utilization. And the gray graph is from the last time interval. And then the blue graph is from the current time interval. And then at the very right, you can see where the blue graph dips below the gray graph by what, like 10, 20%. That's less memory use by ZGC because just the overhead is less when you go generational. And then here we have a different out-of-context graph, which looks at max and average pause times, for example. I was recently yelled at for mentioning average pause times because it is true that those are not that telling. Usually max pause times are something you really want to look at. And this graph is not broken. It's just that on the old scale, this showed up. And on the new scale, the pauses are so low that they don't really register anymore. But they are there. So this graph doesn't stop here. The graph continues, but is very low. So that's the improvement that Netflix saw there. And as you can probably imagine, since Netflix backends are, not sure whether exclusively, but at least in large parts written in Java, and we all watch Netflix a whole lot. So they were really happy with that, right? For them, that immediately translates to lower costs. Whether that applies to your project as well is, of course, depending on your situation. but I think it's definitely worth investigating. The change in 23 now is, because all of this also applies to 21 and 22, the change in 23 is that if you use GGC, it will now be generational by default. And just to clarify this, the default garbage collector is still G1. Just the default GGC mode is now generational. So this is how you'd use GGC in JDK 23, generational GGC in 23. If you're on 21, don't worry, you can still try that. The GC probably got a little bit better since then, but you can still try this, use the same flag, and then you look up one of the OJEPs where it tells you how to enable the generational mode. And if you are interested in performance, you probably already have set up some kind of benchmarking system where you can benchmark your app under load, and then just run it with this flag and see what happens, right? And if it's better, that's great. And if it isn't, maybe it's not for you, maybe it doesn't fit your metrics or your requirements. I linked the generational GGC JEP here as well, because that explains how to use that if you're not on 23 yet. And then 474 is the generation mode is now the default. There's a great article on this. We have some videos on that online. And Stefan Carlson, right, is here, because we have two Stefans. One of them is Carlson, one of them is Johansson. But I think Carlson is here to talk about garbage collection evolution. I think it's on Thursday, and I can highly recommend you check that out. He will go through what garbage collection improvements happened since 8, the big, I think he categorizes like in 5 big chunks of improvements. They will also give you some more detailed advice on when to pick what and how to test and what to look out for. So if you're interested in that kind of stuff, definitely check the schedule. Okay, we're done with features, done with things you get. But you know, life is give and take. So now it's time for me to take something away from you. If you are on a version like 11, you should really not be using any of these 3 technologies because they're already gone. So RMI activation, not all of RMI, just RMI activation was removed in 17. Nastron was removed in 15, but I think it still exists as a separate project. So you should look into that if that's something you're using. And concurrent mark sweep went the way of the dodo because it lives in the similar space like GGC and G1 and just didn't make sense to keep maintaining it. So that's why that one is gone. So those are already removed. But maybe more importantly, all of these are marked for removal. So again, if you use any of these technologies, and we're going to go through quite a few of them now, you need to look into those, and you need to check the links that I give you here to really make sure that you're prepared for what's coming. Don't push that out to the last minute. I mean, you totally can, right? If those, you know, if you're on 11 and they all get removed between now and Java 30, and then you eventually move to Java 33, and you want to rip them all out at once, be my guest. But I think it would be better to prepare and go with the flow here to make sure that you, and specifically your dependencies, don't do something that at least you're not aware of. You should at least be aware of what's happening. Okay, so yeah, let's go through all of that. And then if you have questions anytime, remember, you can ask those. Let's start with unsafe. We talked about it a little bit earlier, actually. Methods for the memory access in unsafe. They have been superseded by var handles and by the FM API, and that's why they will be phased out. Starting in Java 23, if you use one of those, or your dependencies, uses one of those unsafe methods to store stuff off heap, you will now get a compile time warning. Starting probably about Java 25, you will start to see runtime warnings. And then on maybe sometime after 25, you will just get exceptions on invocations. And then after that, the method will just be gone. Right? So that means there's like a clear path here where stuff that's working now will stop working within a few years. The way to experiment with this, because it is often not your code doing that, it is often your dependencies, is to use this flag, sunmisc unsafe memory access, and it has these values, warn, debug, and deny. So this is basically what I said earlier, right? Warn is you get a runtime warning, debug is you get the same with more text, and then deny is we're throwing an exception because we act as if the method doesn't exist anymore. You can already use this on JDK 23 to simulate the future, which is what I totally would ask you to do. If you have a thorough test suite, which I'm sure you do, add sunmisc unsafe memory access deny, just for fun, and see whether everything still works. And if it does, that's great. You're already set up. And if it doesn't, take note why and where. Report those issues to your dependencies. And remember, much of this is open source. Much of that is done by some lonely girl or guy, like, you know, at 10 p.m. in the evening trying to fix some bugs. So maybe help that person, maybe do it like contribute to a bug bounty or something. This is something where if there are bigger changes to be made in certain projects, the community can help not just by opening a bug report and patting them on the back, but also maybe giving them some financial freedom to do this. So yeah, this would be a way to fix. Oh, of course, fix it yourself, open pull requests, all that good stuff. So yeah, that's something that if you observe this in your dependencies and it is important for you, so you cannot just replace it with a different dependency, look into how that can get fixed. Next one, agents. So first, what is an agent? An agent is a component that transforms bytecode. Bytecode of the stuff that the compiler generates, right? The compiler creates these class files, that's bytecode. And then the runtime loads the bytecode, does a bunch of work on it, and then executes that bytecode, initially as a state machine, and then it does the just-in-time compilation, all of that. An agent interjects itself between the loading and the processing of the bytecode and just changes the bytecode. And it does that, for example, to inject logging maybe, or metrics measurements. You can do aspect-oriented programming that way. So that's of things that they don't all have to be agents, but agents can do that. That's some kind of common use cases for that. It uses the JavaLang instrument, a package, or JVMTI. And there are two ways to do this. You can either do this at launch time, which is what you often need to do if you want to inject certain metrics that you want to keep measuring the entire time. Or you can do it dynamically. You can say, while the JVM is still running, oh, by the way, I found this. Then just plug this in to attach this to the JVM, and then let's transform bytecode on the fly. And that's really powerful. But it can also, just like the agents you attach at launch time, it can basically do everything, right? Remember, it transforms bytecode. So it can transform system.println to rm-rf/, right? That's totally an option. So that's why they are pretty powerful. And that's why a certain step needs to be taken to make sure that you know when that is happening. So dynamic agents will still keep working. Every mechanism that I mentioned so far, they will still work. And also nothing has changed yet. But in the future, if you want to dynamically attach an agent at runtime, you will not be able to do that unless you allowed it at launch time, that will be possible in the future. So the reason for that is that you should make a conscious decision whether you will allow these powerful tools to operate on your code. And if you want to embed the agent at launch time, you already have to add a command line flag now. But as it is now, you don't have to add a command line flag to be able to attach that thing later. And so that's something that will be necessary. And that's all this is about, right? So the dynamic agents will keep working, everything is fine. You just have to make the decision when you launch. Do I want an agent later, yes or no? If you want to figure out, because this is the thing, right? Some of your dependencies might actually silently attach a dynamic agent to your app, and you might not know that. So if you want to find out whether that's the case, at the moment, since it is enabled by default, you can go -enable, so that means then disable. So you can disable dynamic agent loading, and then you will see whether everything still works. And if everything still works, that's good. Again, you're set up for the future. No dynamic agent does something with your code anyway. But if this now changes its behavior, you need to be aware that you have one of these very powerful things working on your bytecode. And if that's good, and very likely it is okay with you, then you will have to add that command line flag in the future. But you should look into whether those dynamic agents that are doing their thing there are really necessary, and you trust those to not, for example, accidentally crash your application. Because it's very unlikely that they actually want to try to steal your database logins or delete your root directory. It's much more likely that you think like, why is this playing around with my bytecode? I'm not sure I can trust it to do this reliably. Okay, next one. So we're just rushing through these different things that are going away. Next one is finalize. You might know these finalize methods that you can implement. Any object, you can add a finalize method there. And what you can do there is cleanup. This is, to the best of my knowledge, how byte buffer that we talked about earlier does its cleanup. So, because at some point between this object no longer being referenced and the garbage collector having removed it, at some unspecified point in between, this finalize method gets called and executed. And that way, in the past, before we had try with resources blocks, you could clean up resources that you had open, like ports or file handles, all that stuff. This will be finalized, and the reason is this, by the way. This is the reason why this will be removed. I said finalized, so it will be removed. The reason is that there are better alternatives nowadays, and it does have a constant overhead for garbage collectors because they need to do this. That's in the spec, right? And so they need to keep track of these and call these methods. And these methods are not easy to implement. There are certain challenges with them to get that right. So really try with resources is the best approach here, but I'll show you another alternative in a second. Anyway, so the last point is the reason why they are getting removed. You can, once again, you see the pattern here, right? You get a warning at a talk like this, so if you read the JEPs, or if you watch our videos, or any other content we produce, we'll repeatedly point at these things. So we tell you that this will happen. Then you get a command line flag to simulate the future where it happens. You often also get a command line flag where in the future, where it already happened, you can re-enable it for a couple more releases, just in case you didn't get the memo. And then in the end, at some point, though, these kind of flags will always disappear. And at some point, these features will always be gone. So you have to do the transition at some point. So that's the plan here. So what you need to do is you look at your own code, whether you have any finalized implementations. And if you do, you want to try with resources. Try to find a try with resources way with auto-closable to do this, which works in like, I don't know, 90+% of the cases. If it doesn't, in the rare cases where it doesn't, look into the cleaner API. And if you look at that API and think like, that's not that easy to get right, true, same is true for finalize. The problem with finalize is it seems simple, but it's really hard to get those things right when it comes to threading, when it comes to which objects are still reachable, when it comes to how do you not accidentally resurrect the object you're working on. There are a lot of pitfalls, and the cleaner API has some of them, but fewer. And try with resources has none of them, but has less degrees of freedom. Same for your dependencies, which are also likely gonna, if you have any trouble, just as likely your dependencies as your own code, so check those as well. And again, if you find issues there, maybe help them fix it. And you can already do finalization disabled now, and then again run like a thorough test suite of your system and check everything resources related, like maybe ports or file handlers. Do those behave the same in both runs with and without finalization? Question up there, I think. So the question is, will the finalize method, if it's present, will that cause a compile error? And I don't think it will. I've not read that in the JEP. And it's also be kind of weird, right, to basically forbid a specific method name. So I haven't seen that. So I don't think it does. So I don't think the compiler will do that for you. Let's talk about the security manager. The security manager is a set of checks and permissions. And the intention here is that it's there to safeguard every security relevant code section you have. So you have code where you say, okay, like not just every other code in my JVM can touch this, only specific can be touched under specific circumstances. And this is what you would use the security manager for. And it's embodied by a class of the same name. Security manager is also a class. I claim here it's barely used. So I want to ask here, on your projects, who actively uses the security manager? If you raised your hand, I didn't see you. Can you yell? Otherwise, I'm going to say 0. Somebody points that way. Somebody did there say, okay, so maybe 1 then. Okay, so not many. Good, that's my understanding as well. It's good to get that confirmed. I mean, we're not representative here, right? But just like it's good to see that. The thing is that on the implementation side, it's kind of maintenance intensive. So people in the JDK doing development, so many features touch on that there's always an extra burden, that and serialization. There's always an extra burden in making the new features work with this mechanism. And that's just, if barely anybody uses it, but it costs a constant maintenance burden. And also there are good alternatives for many of the features that the security manager offers. That a decision was made to remove it. It's already disallowed. When I say already, by the way, I'm also talking about the newest version. I'm talking about 23, right? If you're on 17, it has not already been disallowed by default. I'm also talking about the newest version. So the newest version, it's disallowed by default. You can re-enable it with allow, and as before, at some point, this will not be possible anymore to re-enable it. So what you need to do, if you are running on 23, you just observe your apps with those default settings, and the security manager is already disallowed, so you see whether everything behaves as before. And if you do use that class, if you do things with it, then look into that and look into the JEP for alternatives. The JEP also links it, all JEPs always link the mailing list that is responsible for that change. So look, if you have any issues, write to the mailing list and ask them what to do about it. Okay, we're coming to a close here. A few more things that are being deprecated are the constructors on primitives. New integer, new double, all of those. The reason is that Valhalla wants to turn them into value types, Well, that means, I'm not going to go into much detail here, but it means that those types don't have identity. If you if you do new integer 42, and then again new integer 42, and you ask them, are they equal? Two equal signs. Are they the same as what you're asking? Then the language will say, no, they're not the same. You told me to create 2 instances, and I guarantee, the Java language specification guarantees that a call to new creates a new instance. Now Valhalla comes along and says, you know what, this having 2 different 42s is kind of bonkers, so I want to have integer work in a way that you cannot distinguish 2 different 42s because they're the same freaking number. So it wants to take away this identity, this thing where 2 integers can be different, even though they're the same number. But that collides with the constructor, right? Because the JLS says the constructor gives you an instance with a new identity. And so this cannot both coexist. And instead of not getting value types because of that, we're not getting those really useless constructors. So they go away. That means that if you do use them, you will get a deprecation warning. And if you do identity-based operations, like locking, for example, on an integer, which please you don't, I hope, then those will be in trouble too in the future. So instead, you just go integer value off. So this is a very simple. You can probably do a search and replace, but otherwise something like open rewrite will do this for you, and you can do that. Okay, so in the beginning, right, and I didn't talk about the Windows port, but I'm sure there are people from Microsoft here, you can ask those. But basically, it's an old 32-bit Windows port of the JDK that very few people still use in production, and since Microsoft is maintaining it, they rightfully said, maybe it's time to phase that out. So that's also being deprecated for removal. In the beginning on that slide, I linked all the JDK enhancement proposals. If any of those things were like, maybe we are doing that, please read those. This was just very superficial information. Those JEPs explain why, explain the detailed process, explain to you the alternatives. That's the place to keep working on this. Although I did make another video summarizing that, but you really kind of got the information you needed here. Okay, good. So it's now a little bit after 11:45. We can go through all of these after the break. And since, as I said, I want to give you time to filter out and come back in, I want to say 10 past. So 11:10. I'm going to start on the minute. I'm going to say 11:05, but I'm going to start at 11:10 on the minute. So it's like, don't be late. At 11:10, we're going to start again with all these preview features, and I see you then. Have a good break. Okay, so while the rest filters in, I forgot a git push. So the slides that were online were not the exact ones that I'm showing here. You might have noticed that they don't actually have the DevOps logo on them because they were from the previous conference. So if you are looking at the slides, you F5 right now, or Control-R, whatever your operating system makes you do there, to get the actual version of the slides that I'm showing. And in case you didn't catch the URL, it's there again. Yeah. And one more thing before we get started. We had a question earlier. Maybe the gentleman can raise his hand. So we had a question earlier about an unused accessor in a record decomposition, whether it gets called or not. Came from somewhere there, right? There. Okay. So the answer I gave was actually not correct. So the question is, when you deconstruct a record into name, let's say first name and last name, and I set the accessors who will be called. So we call first name and last name the methods. If I do not use the last name and just go first name and then underscore for the last name, what happens to the last name accessor? It does get called. The reason for that is that even though you're not supposed to, you might be doing something in that accessor that changes some kind of global state. It has some side effect. It does something, again, probably nasty that it shouldn't, but it does that. And the logic is whether that code gets executed or not should not depend on whether you end up giving that variable a name or not. So that means if you deconstruct a record, all the accessors will get called. That is the semantic. Now, in real life, most of those accessors probably just return a field. So if you're running, if that code is hot, if the just-in-time compiler optimizes it, it will probably figure out that returning a field that is not used is dead code. And that way, while it's semantically always called, it might not end up being called in practice if the call does nothing. If the call just returns the field, it can just be elided. And then the just-in-time compiler may or may not figure that out. But semantically speaking, yes, it is called. It should never matter because don't put anything like that in your record accessors. In fact, I've been using records a lot in the last couple of years. I think I've overwritten maybe 2 accessors. There's barely ever a reason to do that. Okay, I don't like Mac, so that's why I'm hiding the apple. Okay, that I shouldn't have said that. Anyway, it doesn't matter. Can I get a full screen here? There we go. Okay, good. So we have all of these topics in front of us. Some of them are short, some of them are long. I'm not sure we're going to get all of those done in like the 75 minutes that we have left. But I think I'm just going to start at the top because I think we have a good chance that we get all of them done. And you might even get a few minutes of your time back today so you can start the lunch break early. Let's just get going. Let's talk about primitive patterns, which again, we have the author of here, so that's great if any questions. I'm going to recap a little bit of these of instance of and type patterns and switch, and then we're going to fold in the primitive patterns. So if you use a pattern, these are some of the things you can do with them. If you have an instance of or a switch, you can match against a specific reference type. You can ask, is this variable that I have here an instance of string or an instance of user? If user is a record, like first name and last name, you can deconstruct the record. You can nest patterns. So if you have a record containing records, you can take them apart all the way down. And as we saw with the underscore, you can ignore parts of the pattern too. And furthermore, in switch, on top of that, you can use guarded patterns to say, let's take if, so let's say switch over the object. In case it's a user, give me the name, and then you write when the name is not empty, for example, right? And then you do something in that branch. So all of that works. And that plus seal types are what I would call the pattern matching basics, what we went through in this earlier example as well. And now, on top of that, we'll just get more features. But that's not the only development that is happening. I call the other thing not building up, but building out. Making sure that now we have this new functionality and semantics, it works equally across all the parts of the language. And it doesn't just, in this case, what I talked about so far, I called them reference types, because all of this has only been working for reference types. But we have primitives. I mean, we can switch over them already. So it's kind of weird that they get not mentioned in this at all. And to talk about this semantics and the evolution here, if you have an X instance of Y operation, you're basically used to ask, is X of this type? Is X of type Y? And now it kind of asks, does X match the pattern Y? Right? So we really have, if you start using pattern matching, we all have, I think, like a visceral reaction to every time we type instance of. We feel kind of dirty because, oh, we're not supposed to do that, right? Object-oriented code doesn't need type checks. And that is true, and that is still true. But you can do more with instance of now, right? You can say, well, I already know it's a user, but I just want to take it apart really easily. So instance of no longer means, is it of that type? It means, does it match that pattern? And that pattern might just be a type name, and then basically, does X match equal to type Y? You get the same meaning. But if it says, does X match the pattern? Can this be deconstructed into these kind of components? Then you get a different meaning, right? So instance of evolved its semantics. So the old semantics did not make sense, right? Is X an instance of byte? Well, I mean, is it declared as a byte? If yes, then yes, and if no, then no. The question is really pointless to ask. Like, the compiler can already tell you that it's true or false. So that made no sense. But the new semantics can make sense. We have one here. I have the number 0, and then can number be an instance of byte? In the meaning of, like the original meaning of the word, can this be an instance of that? No, it's an int. Like, that's what it's declared like. But can its value be a byte? So not like, can this variable be of that type? No, because it's of a different type. But can this value, does that map to byte? Does that make sense? Yeah, totally. This is a byte, right? 0 is a valid byte. And so in this sense, it does make sense to expand patterns to primitives. So here we have, we start with X is 0, and then we ask, is X an instance of byte B? And now we're asking it, does X match this type? Does that make sense? And the answer is yes. If it's in between minus 128 and plus 127, then that can totally be a byte. And otherwise, you get this else there. So this is something that is now a preview feature in 23 that you can use instance of, but also switch with these primitives. We'll see more examples later. But I want to give you a more interesting bound check example, because this one you'll be like, okay, that's kind of nice, but you could also have written like larger than this and smaller than this. Like, this is just a different way. It's not even much shorter than to write the same thing. Okay, but we have a better example for you here. What's special about 16,777,216? And not to put any pressure on you, but when I asked it as Java zone, somebody gave me a really good answer. So, you got, no? Oh, wow. You're worse than the Norwegian guys? Okay, so the answer I got, wait, isn't this 2 to the power of 24? Which turns out to be true and turns out to be actually germane to the conversation here, but I didn't know that. The answer here is that's the smallest positive int that cannot be a float, or at least not exactly. And that is because of the way that the float is written with the exponent and blah, blah, blah. So that means this int cannot be a float. Which is interesting, though, because float does have a much wider range, right? And here the interesting thing is whether something is a float is no longer just a range check. It means what other things can happen or can't happen. So if you do this and say x is this number, if x is instance of float f, then you can use f here, but this number would fail that test. Not because it's larger than the largest float. It isn't, by a long shot, but because it does not fit neatly into floats representable numbers. So that's kind of cool. So if you have checks where you transform between primitives, those should get simpler now with these. This is the pattern, right, and used in instance of. Then we have this one. The tri-state Boolean. Who doesn't love that one? When you get like a Boolean which could be potentially null, and you now want to figure out what is it though, and you need to have all three cases. I want to say this now works, but it doesn't yet. It works in the 24EA builds, and it will work in 23.01 once it's released. It's a little bit bugged in 23, but it doesn't matter. It will, work soon enough. Where you can switch over a Boolean that might be null, and you just write the obvious thing, right? In the past, you were first done, is it a null check, and else do this or do that. This just makes much more sense, and it's just easier to write. There are a few more examples what you can do with this, what you couldn't before. But the important part about primitives in patterns is that it makes sure that these new features that we built will, well, I say we, I don't build them. The new features that OpenJDK built don't just apply to like the new pyramid that they're building, but also applies to everywhere else where it makes sense to keep the language uniform, to keep more concepts that apply here that should also apply there to actually apply there and not confuse people who are like, why does it work here and not there, right? So this is one of the improvements that are being done. I'm sure there will be more built on top of that. Again, a JDK enhancement proposal and a video if you want to look into that. Okay, any questions about that? Yes?
Not really a question, but
More of a comment, Mario.
I don't know. I don't think I find myself using this stuff. I don't know.
Yeah. Right, so Mario says he's not seeing himself using that stuff. I think this shines when you deal a lot with primitives, which is not something that the typical, object or even functional programmer does a whole lot, right? We don't, we don't push numbers around a lot. I think if you push numbers and you take them out of one context and put them in another context, then this does become more important. But yes, I'm not selling this as, this will solve all your problems. That's why I emphasize that one important function of this is just not to keep like an imbalanced language where things that should work across it don't, because it's not that useful here. So yeah, I agree. Like I'm not going to use it all. Although this one I already tried using. That's how I found the bug. So like it's not zero use cases.
We're missing the case of the for possibility Boolean using the optional Boolean.
Oh yeah, right. It could be optional Boolean. The option could be not. Also, I'm missing a semicolon for unbelievable. Let me. Oh no! If I fix that now, my preview doesn't work anymore. Okay, so let's not fix this. You just have to live with it. There we go. Okay, good. More comments / questions? Okay. Oh no, there's one right next to Mario. Yes.
I have a question about how this is actually implemented. The one related to the byte, the bound check.
Yeah.
Is it just a syntactic trigger that the byte would provide just the actual bound check, or
So the question, how is it implemented? Is it just for byte, for example, really just the bound check, and then probably also how does it work with float? That's actually interesting. I will forward you for later to my colleague Angelo, who sits here, who done that, and then we can. I want to know the answer too, but maybe that might be a little. Or do you have a short answer that you want to give now?
the short answer is that our first
Just let's talk here.
Our first inclination, like gut feeling, would be to do a round trip cast, and then would say like, oh,
if I want to go from an int to a float, then in order to check that if I lost information or not, I can go back to an int and then check if the original. Oh, and then I'm happy. But no, this is not the right answer, because there are many details with car, for example, like this is a narrowing and widening conversion, and then float and double have some other details about equality. So it's a little bit more evolved than that. So we have specified all of these exactness criteria for all possible cast conversions according to Chapter 5. One cast conversion was from reference to reference. Instance of checks that. And the VM knows how to check that, what he said about the types. But for all the rest where values are incorporated, there is a very well-specified plan on how to check these things.
Okay, that sounds like a lot of work.
Yeah.
Okay, everybody heard that, right? So basically, it's hand-coded for all reasonable combinations. Okay.
And some, they don't need at all.
Right, if you ask a byte whether it can be an int, that's trivially true, right?
Yes.
Yeah, okay. Good. Okay, let's talk a little bit about imports. Again, show of hands. Who prefers, the second one is a star import, right? I want to make a prediction here. Okay, my prediction is that like 80% of people prefer, maybe 90 even, option A, but people do use option B. So which one do you prefer? Do you prefer option A, like explicit imports for everything all the time? That's basically everybody. B? That's a few people, yeah. I think my guess was about right, maybe 9 to 1. And that's fair, right? Like I know that some IDEs, for example, collapse once you've imported like 5 types out of the package. It's basically saying like, look, clearly you like this package a lot, so let's just turn this into a star import. So yeah, option B, star imports are being used. The upsides is clear, right? It's more succinct. It's easier to manage manually, specifically if you do demo or if you do, have some experiment that you're doing in a local file, for example. If you don't run an IDE, it just is easier to use. The reason why most people don't prefer it is because it's less clear. You increase the chance of conflicts, although those can be resolved. And it feels like a little bit arbitrary, right? It's not like every package is a coherent API. There are packages that need other packages to work, but you're just importing one half of that. So that's not ideal. This is where module imports come in, which you could describe maybe as star imports on steroids. So you just say import module and then the name of the module. And then the short answer is it imports the public API of that module. We're going to go a little bit deeper into what exactly that means in a second. So it imports all that public API. And very importantly, because I know that everybody's like, modules, nobody uses those. Your code doesn't have to be in a module. So you can import Java XML, for example, and then you get the entire Java XML API without your code having to run in a module. And that's a preview feature in JDK 23. So what exactly does it import? So it imports all public top-level types in the packages exported by that module. And that makes sense, and it's simple enough, and mostly that's what you should think about. But if there are qualified exports involved, then the packages exported to your module from that module will also be visible. So if you have a module, and that code says, these 5 packages are my public API, but this extra package I'm exporting to your module, then of course it makes sense that you would also read the public types in there. And then if somebody uses implied readability, requires transitive, then you can also read that. So if you don't use modules, this might seem like a somewhat weird and complicated and arbitrary list, but if you dealt with modules, this is very straightforward, because this is just the public API of mod for your module, and these other 2 bullet points belong to that. So yeah, if you don't use modules, but you want to start using them and get to know them better, at the very end I'll give a recommendation for the book that I wrote about it. If you want to be like the first person this quarter who bought it, I would appreciate that. No, it's like, okay, let's keep going. So module import. So the upsides are they're even more succinct, right, than star imports. They're even easier to manage manually. They still have some of the downsides that star imports have. They're less detailed. Conflicts are even more likely. But one downside is missing, which is you get an arbitrary slice of an API. And I think this is really a strength. Writing import module Java XML really signals clearly, okay, you're doing something with XML in this class. You're getting all the API for that, so that's good. Short word on conflicts. I'm importing Java Base explicitly here in Java Desktop and Java SQL. And in this example, I'm using date and I'm using list, and both of those are ambiguous. because date exists in base and SQL, I think, and list exists in base and desktop. So I have to resolve this in this way. Also, just don't use Java util date. I don't think I have to add that, but it makes a good example here. Right, so if you have conflicts, this is how you would resolve them. So I would recommend to you to use module imports when you're already using star imports. If you don't, and you're like me, like all of those imports to be very explicit and detailed, then that's great. I'm not here to tell you you shouldn't do that anymore. Quite the opposite. Keep doing that. I think that's a good approach. But if you are liking star imports for the reasons that I outlined earlier, or maybe for other reasons, then I think module imports are probably going to make those reasons more pronounced and take away a little bit of a downside. So I think that's straightforward then. And then, again, outside of an IDE, just experimenting with something. Maybe you want to demo something to somebody. Maybe using the playground, dev.java/playground. Go check it out. You can write Java code in your browser. You know, in those places, it's just better to write import module Java XML than like, you know, although you probably don't want to demo XML. That's a different thing. So yes, if you do want to demo XML, it's probably easier to import the module than just individual packages. And as I mentioned earlier, an implicitly declared class, I said, well, it imports, you know, Java base API. This is how it does that. It basically implicitly uses import module Java base. So if you write just this simplified main method without a class body around, then if there is no class body around, you get the import of Java base for free. As soon as you start adding the class, you have to also add the import. And then you get, for example, what list and stream and big decimal and local date and random generator. The code really doesn't make sense, but doesn't matter. Like you can use all of these types now without having to explicitly import them, which is really cool, again, for a beginner to start working. They probably want to experiment with arrays, with lists, you know, these simple data structures, maybe a little bit of datetime parsing. And it's really good that file.io as well. And it's really good that those things then just work out of the box and they don't need to busy themselves with importing the right stuff, which specifically outside of an IDE is kind of troublesome. So even of the types I use the most, when they don't live in Java util, there's a very high chance that I don't know which package they come from because I don't know that by heart for all the types that exist out there, clearly. Again, if you want to learn more about that, there's a video about that to go and look into that. Can I customize? Can I customize the default import? No. It's like the compiler just says, okay, when you're not having a main class around this, you're probably doing simple-ish stuff, and for that you need Java base, and that's it. What you can do here, I mean, what you can write on top, of course, import Java XML. Import module Java XML, that works. But there's no way to embed, to tell the compiler always import these three modules. That does not work. Okay, string templates. Who here watched a talk about string templates, maybe by me, and was like, that looks great, I'm going to use that, I'm going to experiment with that, and wrote some string template code, and now is faced with having to rip that out again? Few people. I'm very sorry. I had to do the same. I have a project that's unfortunately not yet open source. I hope to change that for the next couple months. Yeah, I used a bunch of string templates in there, and when they got removed, I had to go through that and remove that. That was not fun. But it is what it is. I'm here to explain to you why string templates were envisioned and why the current proposal was not adopted and what might happen when, or what might happen next and when. So the idea behind string templates is to make stuff like this easier, right? So what we're doing here is, and yes, don't take a photo of the slide yet. I'm going to get there. I'm creating an SQL query by just embedding these string values, right? So I want to say select star from person where last name equals Doe, and for reasons I have the property and the value up there. And I can do that with just regular string concatenation with a plus, or I could use string formatting, and I could use message format again as well. That's like the third way. But all of those ways are not really very straightforward, but also they come with a free SQL injection. Now you can take a photo of the slide if you have to. Other languages make that easier, right? Why not do something like this, where I can just, you know, the two fields, property and value, are still up there, where I can just write this like this. You know, it could be one line, but forgive my code highlighter, my slide size, sorry, where I'm just saying this is a reference to the variable property, and this is a reference to the variable value. And I use / curly brace already here because that's gonna show up later again. But other languages allow me to do my code SQL injection much faster. Can I have this in Java? No. So, you know, let's try, if we make string concatenation easier, let's try to hit a sweet spot where it is easier than it is now, but it doesn't perpetuate the inherent insafety in putting strings together simply like that. Because it's not just SQL injections. Every time you create strings, you either create it for humans to read or for a machine to read, right? Sometimes both. And if you do it for a machine, it's almost always some kind of structured format. And that's a lot of the strings we produce. Basically, if it's not UI and it's not an exception message, it's very likely that it's going to end up in some specified, pre-specified format. And all of those have validation rules. They need to be sanitized. Some of them come with an injection risk. SQL clearly more than others, but for many of them it does exist. And all of that follows format-specific rules, right? YAML and JSON and SQL are clearly going to solve these problems very differently. And so it would be nice to find a way to make this both simpler and safer. And this is what String Templates proposal in Java 1 and Java 22 previewed. So now I'm using a text block, but that's irrelevant. I just use it so the formatting is better. It works with text block and simple strings. Here I'm using, again, the select star from person P, and I still use the / curly brace syntax because that was the one that was proposed. And the important part here is that the text block part, because it contains this / curly brace parts, it's not actually a string. It's not a legal string. / curly brace is an illegal escape sequence in Java. So this cannot be a legal string nowadays. It's an illegal string, but it's a legal string template. And a string template in this old proposal needed to appear right next to what's called a template processor. They appeared right next to one another. And so there always had to be both of those things there. When I use a string template, I needed to have a processor. And that meant that I'm forced to pick something there. And if I'm forced to pick something here, then I might as well pick the right thing. That was the idea behind that. I'm doing something with SQL, so I'm going to use the SQL template processor. And that one, as an added bonus, doesn't give me back a string. Because why? You probably want to run an SQL statement. So it gives me back a statement in this case. This processor did not exist in the preview, but you could code it up yourself and it would look exactly like this. Okay, so this is what it was in 21 and 22, and then 23, finalization was being considered, and then the decision was made maybe not to. So, or not maybe. This syntax was a lot, right? Like it's very different from what Java usually does. This SQL thing is just a static instance. I mean, it doesn't need to be static, right? It's just an instance of the interface template processor. What this is really doing, this is calling an instance dot process was the method, passing a string template. This is just a regular method call, but it got special syntactic sugar because if it doesn't, then will people really use that over concatenation? I don't know, but on the other hand, like it really comes with a lot of extra baggage. People have been begging for not to have to write f.apply5 to have their function apply to the number 5, but just be able to write something like f.5. And I was like, no, it's a Java method call. You have to write it as a method call. And now this, of all things, get the special syntax. So anyway, that was an important consideration. The other part is that the reason why they had to appear side by side was that Java string formatting is really slow compared to concatenation. And there were some special hacks / optimizations, however you want to call those, that could bring the performance of the formatting template processor that would accept the string format kind of strings there on par almost with string concatenation. Like it would really make it much faster. But for that to happen, the thought was that this processor and this template need to appear side by side in the bytecode for that optimization to be applicable. And apparently it turned out, I'm just recounting what was said on the mailing list, and apparently it turns out that that's actually, like, it's not correct. Like, there's actually a way to make this work, this improvement, without having to appear those things side by side. So one of the big reasons for those to appear side by side, to force them there, disappeared. And so that's why then the syntax became a little bit too much to carry its own weight. So they were removed from JDK 23. They're not even a preview anymore. The feature needs some kind of redesign, and it's questionable when that's going to happen. So I've not seen enough movement on this to be hopeful for something in 24. But I don't know. Like, so I'm mostly using just external information. I try to limit, or at least hopefully entirely exclude any internal information. because I like to talk a lot, and if I ask Brian something about what is this secret thing you're planning, and if he actually tells me, I cannot tell you, that drives me madder than just not knowing. So that's why I usually don't ask about what's the plan here, what's the plan there. Gavin, I know that Gavin is kind of working on this. Gavin Bierman is also yet to ask the architects, to just ask him what his plans are there. Right, and I don't ask him, because if I do, I couldn't tell you, that would be boring. So I base this on public information, and publicly I haven't seen a lot, so that's why I'm guessing maybe not in 24. I'm not sure. If you've seen this proposal come and go, and you're like, yes, those / curly brace was terrible, I'm glad the proposal is dead, I got really bad news for you, because that was not the critical part. The / curly brace is probably going to be around for the future. If you want to check all the details, I link to the mailing list discussion here, which is huge. Like, it's just huge. I actually wanted to add a screenshot here. Maybe we can just, I think I'm online now. Can we do this? Oh, there we go. See? So, just be my guest. That's what I do, so you don't have to, by the way. So yeah, long discussion about all this and all kinds of details. I tried to summarize them a little bit more in this video, but the gist is, because it's very speculative, I don't want to spend too much time on this here. The gist is the preview is out now. It may come back in the future in some other form, and then there's a little bit of speculation about what that might look like in there. But it's probably going to still be the / curly brace, very, very likely. Okay, get questions about the string template removal, because that got quite a lot of feedback and discussions on Reddit and on Twitter and everywhere else where people talk about Java. Okay, take that as a no. Oh, there's one there. Yeah, so the question is, why keep it, or why not keep it, and why remove it? So the idea behind the preview feature is that a preview feature is basically done, and because we now have this benefit of a 6-month release cadence, OpenJDK can say, okay, instead of freezing it and standardizing it, it can now be around for 6 months or 12 months longer, and then we freeze it. So the idea is that a feature that is in preview is not an alpha or beta version of a feature. It is done. In the past, it would have been finalized like this. We just want to give it some air to breathe and maybe see whether we need to make any changes after all. That's why most changes in previews have been very minor. A feature that is already known to not exist like that does not fulfill those criteria. And we already asked a few people already said, yeah, I had to change my code. And the longer you leave that out there, the more code will be written on that, already knowing that it might either have to change, maybe a lot, or have to be entirely removed. So that's not really that helpful. So instead of gathering more feedback on a proposal that's already bad, with a piece of code that already, with more people writing code that needs to be changed, so that's why that decision was made. But I don't think it was I don't think it was discussed at that depth. It's just preview features have a very clear definition, and this very clearly doesn't fulfill it. So that's why it just was culled. Actually, that's not true. There was a short part of that thread did discuss that. But the proposal to remove it was just universally adopted immediately. Hope that makes sense. Okay. Dude, we're going through this. You get a lot of time back, it looks like. This will be my first talk where I don't have too much content, ever. And I've been doing this for a couple of years now, so that would be good. Maybe, maybe stream gatherers, I can waffle a bit, because that API is pretty cool. Okay, let's talk a little bit about construction and how to create objects. Specifically about constructor chaining. Constructor chaining meaning your class has more than one constructor, and instead of every constructor doing the full setup, you call one constructor from the other. So you say, okay, that's the big one, that has all the arguments, that's going to do the right thing, and the simplified constructor is just going to call that one, and maybe there's a little chain of that. That's what we mean by constructor chaining. Constructors calling other constructors. And I would argue that is generally good practice if that works, if the logic allows for that, because you want to you don't want to duplicate these checks, right? You want to have 5 places where something is checked, because then maybe if you change the check, you don't notice in all 5 places. So if you have one place where all the arguments are checked and all the fields are assigned, that's good. If you can make it work. It doesn't always work depending on the logic, but that's good. And then other constructors just forward there. So I would consider that would be a good piece of advice in general. So here, for example, I have a class name with 2 fields. And then I have the obvious constructor that maybe does some checks for null or maybe for length or whatever, and then it just assigns those. And then I have one constructor that only has a last name, and so it just forwards to the other one. Yes, this could also have been a static factory method, I'm aware, but because I want to demonstrate constructor chaining and the examples need to fit on the slide, it's this example. So yeah, this is what I mean by constructor chaining. All the checks would be here, and this one just forwards there. If you have superclasses involved, other than object, wrong, that actually is even the case for object, then you will have to make a super call somewhere. So here, I have a 3-part name, which extends name, which also has a middle name now. So I get first, middle, last, and I need to put this super first, last in there. If I don't, it doesn't compile. And the only reason why if you have deeper class hierarchies, you don't always see a super is because the superclass apparently has a parameterless constructor. And then you do not need to type super parenthesis. If the superclass has a parameterless constructor, this method super parenthesis is called first and implicitly. Okay, so that's this setup. Now the problem is, or the situation we're in, is that Java does not allow statements before this super call or before this call. The reason for that is that the superclass should be initialized before the subclass runs any code. So if the superclass has certain fields that are getting assigned, the idea is that the 3-part name will only start accessing or writing stuff to fields, or accessing fields actually, after the superclass constructor was run. The reason being, if the constructor of the 3-part name wants to access one of those fields, then it already needs to have been initialized. So that works best if you just force super needs to be called before the code in the constructor down there does anything useful. And so that's the basic rule, that you need to call super first before you do anything else. And because if you run something before this call, if you could do that, if you could run code before this call, for this constructor call, and then this constructor call is the one that calls super, then you had again code before super. So really the reason is no code before super, but that immediately translates to also no code before this. This made sense as a rule, right? So it makes sense why you won't want your superclass to be initialized first, and the way to enforce that would be to create this limitation. But it comes in really cumbersome in a bunch of places. If you want to make more complicated arguments checks or preparations, or you want to split or share something, you're often in a situation where that doesn't quite work. And when I said earlier, I would recommend constructor chaining if possible, the main reason why it's sometimes not possible is that you want to do one of these, and you only can do that if you could have some statements before super. So as an example, let's say the name constructor that gives you like a full, you get the full name, which is first name space last name in this very Eurocentric example. What you want to do is you want to call the other constructor that takes a first name and a last name and want to split on the space, and you want to, once use the first part and then use the second part. Now, splitting a short array twice is really not a lot of work, and this is a really pointless optimization to be like, but how can I only call this once? But it still feels natural to us. This looks bad, right? Like it just looks not good, and also you're like, in this simple logic, probably not, but in more complicated logic, if you do the same work twice, you might accidentally not do the exact same thing twice. So while this specific instance is not terrible, it's also not great either. We kind of feel like that shouldn't be necessary. We would like to do something better here, which is this. This is what we like to do. We just say, okay, split the name into an array, and then just, do these assignments. So this is something we can do, but here now we don't get the constructor chaining benefits anymore. Whatever checks we want to apply to these two, now we have to repeat those checks here. Right? So this is an example of what I said. This is an example where you could not chain the constructors because of this rule, and this ends up with repeated checks for things. So you avoid the split, but then you get as a cost the duplication there. You can do something like this, where you create intermittent constructors, which is it's a hack, right? You just do using something that the language allows you to do, but you wouldn't want to use it in the first place. So you can create, that doesn't always work, but sometimes it works, that if you want to prevent repeated work, that repeated work gives you an intermediate result, and then you create an extra constructor that takes that intermediate result and does the right thing there. So yeah, that's, again, is a solution, but isn't a nice one. This is, oh, right, sorry. This is the static factory method, right. That's good. I like static factory methods in general. Records kind of like screwed with that ideal with me for a bit, or for a while, because they always have this public constructor. But I kind of like having static factory methods. And if you do too, then this is a good way to work around this problem, because there clearly you can put all the code there. But that also means if you do have a visible constructor, then people might be used to just writing new your type and then find out which constructor can I call. And if there are like 3 constructors and 1 static factory method, the static factory method is not really discoverable, because why would the user know that they now have to switch from the one construction protocol to the other construction protocol? Again, none of these are terrible, right? Don't get me wrong. I'm not saying, oh, this is terrible and how I've been coding like this. But it's not ideal, right? It would be nice to change these things a bit. And records come with an extra limitation, because they do want to enforce a uniform construction protocol, and they require you to forward to this. With a record, you cannot have a second constructor that assigns the fields. They all need to do the same thing. So this solution that I showed you earlier, that just plain doesn't work with the record, because you have to forward to the this constructor that takes these 2 arguments. Or to some other constructor. It doesn't have to be that one, but it has to be some other constructor. You cannot assign the fields outside of the canonical constructor. And this is what we really want to write, right? I'm giving this example on a record, but the same would be true for a class. This is what we want to write. We just want to say, just split the damn thing, and then let me call the constructor with those 2 fields. How hard can this be? And the answer from JDK23 is yes, it's not actually that hard. As I said, this limitation was put in artificially to safeguard something important. But that important thing can be safeguarded in a more relaxed way. And that's what Project Amber has been exploring and is now previewing in JDK23. So you can now do this. So here I do have the class from before with a 3-part name that extends the other class. And now I can have my checks for middle, for example, here. That's definitely a typo. That should be middle. Oh, no, it's not. OK, that makes sense too. So the point is, I do a check, then I do the super call, then I assign my field. So the straightforward thing that we're thinking now works. It also works if you need to prepare something. Here, for example, I have the middle name. Maybe I want to shorten the first name if a middle name is present. So again, I want to run some code before I do the super call. So those things are now all possible. You can split arguments as well that way. Again, having the call here and then do the super call. So that's all good. What's really surprising that Project Valhalla might actually benefit from this. So what I've told you so far is just syntax, right? So it's a little bit relaxed. What you can do here, by the way, in these blocks is limited. You can think about, imagine I were in a static method. What could I do in a static method? That's pretty exactly, but not quite, what you can do in this pre-construction or pre-initialization context, what's called pre-initialization context. Up here, before the super call, what you can do there is basically like in a static method, with some exceptions. OK. Project Valhalla comes in here and says, that's kind of handy. I actually need that. So if you've not been following that, then what I'll tell you now might not make a lot of sense. That's fine. There's going to be sessions here in Valhalla as well. So Brian's going to give one. He's going to explain all this in detail. So if you already, if you don't know this, then that's fine. It's just going to be this single slide. But for those of you who do know about Project Valhalla and what the current developments are, Valhalla does ponder non-nullable types. And the idea is that you can have a non-nullable field. But what is a non-nullable field initialized to? Null sounds wrong, right? So the idea here is that what if the language does initialize them to null, but then forces you to initialize them in this pre-initialization context? So before a super call, you're forced to write something to your non-nullable fields, and then nobody can ever observe that the non-nullable field was actually null for a couple statements because nobody can ever read them. So Valhalla comes in here, and I'm going to leave the rest to Brian to explain, to make some, to use this relaxation to put a new rule in place for non-nullable types. So that worked together quite well. But this was not intentional, by the way. So when Valhalla started out exploring how nullability, why that is important, and what can be done about that, and how that could be fixed, they went an entirely different route, and then eventually realized, wait a moment, this could also work, and this makes the program model actually simpler. Again, watch his talk about that. The talk that Brian gave at JVMLS is recorded, but he gives one which is more geared towards us users and less geared towards the people working on OpenJDK here at this conference. I think the same title, so go check that out. And once again, video and the current JEP in 23. I think it might already have been a preview in 22 actually, but I think it got updated and renamed in 23. Okay, do you have questions about that? Where you can now put your constructor arguments? Nope. Or like statements, I should say. Okay, let's talk a little bit about stream gatherers. So I like streams. I like using them a lot. People I trust have made the argument I use them too much, but most of my code is written for just me, so I don't care. I like fiddling with stream pipelines and figuring out how can I get this logic in there. First, how can I get it in there at all? And then maybe later, how can I do it in the way that it actually remains somewhat readable and maintainable? And the problem with that is that intermediate operations in Java that they have they're good, like map and flat map and filter, all that good stuff is there. But there's a bunch more that you could wish for that don't exist. I have a few examples here. Sliding windows. It's pretty great. Like if you want to create like a sliding average, like you have a stream of numbers, and you want to have always the average of the last 5. That's terrible to do with the current stream, with the stream pipeline without this expansion. Just groups, right? You want to just have blocks of, you have visitors in a stream, and you want to just create visitor groups, and you want to say, okay, just give me blocks of 3 visitors and turn them into a group. You have a take while that exists. You can say something like, take elements from the stream while this predicate is true. And once it turns false, stop the stream there. Which is kind of cool, unless you want that specific element in there too. So let's, for example, assume that you say, I want to take out of the stream of log messages, I want to get messages until the first error. So you would write the thing like, okay, so take while, which exists already, take while the log category is not error, or the log level is not error. Which is cool, you get all those messages, but then the error, you don't get the error. And that seems kind of important in this specific example. I had this problem. There is a solution with the current stream pipeline. It involves using an atomic reference and doing some ugly things to it, so that's not good. Scanning, increasing sequences, there's all kind of things you come up with that the Java Stream API does not offer. As a little bit of an aside, the same is true for terminal operations. We have a bunch of terminal operations, right? We have now toList, which is pretty great. We have something like reduce. So we have a bunch of specific terminal operations that produce a final result. But on terminal operations, we also have something else. For all of those operations that are missing, that the writers of the Stream API didn't come up with, to set, for example, we have collectors. We have this idea of what is a terminal operation, what does it do, and how does it work in the context of the stream pipeline, what are those actions that it needs to take, and then that concept gets generalized to those bits and pieces get generalized to the concept of a collector. So you have collector, singular, as an interface. You have collectors dot, a bunch of implementations, right? Before you could use toList, I think since JDK 16, you've probably written collect and then parentheses, collectors toList, maybe with a static import. And you can use toSet as well. And so they're all there. So you have these collector implementations, but you can add your own. And you have one method in the stream pipeline that says, okay, I'm the extension point for that. You give me a collector, I follow this specific recipe, and then we're both happy. I don't have to have like all the possible terminal operations in the world. And at the same time, you get to have all the possible collections that you want to have there at the end by creating yourself. And the idea now is, let's repeat that mechanism for intermediate operations. So let's generalize what an intermediate operation does and how it works to the concept of a gatherer. Then there can be some implementations already being added. Gatherers is a class that is part of this preview that already gives you a few of those operations. But more importantly, you can create your own implementations of this interface and hand it to stream.gather, and then you get your results. So for an example, this is what this could look like. I'm saying stream of some stream, and then I call gather, and this is a static import of gatherers.scan, and it doesn't matter what scan does here, by the way. It's just some intermediate operation, and then I say for each system out print line. So this is how you would use that, right? And you can see how this is very similar to collectors. By collectors, you would put at the end .collect, and then you pass your collector maybe with or without a static import. So let's look at gatherers and how they work. They have one required building blocks and a few optional ones. The required building block takes the current state, if there is any. The initial examples won't have one. It takes the current element that is being processed, right? So every stream operation processes one element at a time, and has a downstream, which is the rest of the stream pipeline. That's like the following operations that you put there. In this case, the scan as a downstream would basically have this for each. You know, semantically speaking, not literally, but that's the idea, right? So downstream is the next operations that come there. Okay, its task is to combine that state, if it has any, with that element, and then maybe it can update the state if it wants to. Again, the first examples will be stateless. And then it does potentially some pushing to the downstream. It can push nothing, it can push many elements, it doesn't matter. So that's very imperative, right? It says, okay, I know what my new state is, and now we'll push 1, 2, 3, 5, whatever, how many elements I want to push downstream. This gatherer, by the way, when I use slides with generics, I don't put all the supers and question mark super and question mark extends here because it just blows out like the slide, makes it harder to follow. But in this example specifically, some of those things don't compile if you don't put in some supers or extends. So if you copy paste the code from the slides, be prepared to deal a little bit generics. So you have the gatherer, and I'm not going to go over the generic signature there. Let's look at the integrator. This integrator has as a state void, meaning basically it's always null. I don't care about the state here. I don't have one. I get no state. I'm already using the unused variable underscore here. I'm getting an element, and I'm getting a downstream. And I'm just pushing the element downstream. And that's all I'm doing. And then I return a gatherer of that integrator. And this gatherer does nothing. Right? If it's not there, it takes an element and pushes it downstream. Right? So this is pointless to implement. I just want to give you this as the simplest possible example, basically the hello world of gatherers, just pushing things through. This is something a little bit more interesting. Let's use a map. We're re-implementing map now. And I can, if you're interested in this, and if you want to play with gatherers and you want to get to know them, what I can recommend to you is just take the intermediate operations that already exist on the pipeline, on the Stream API, and just re-implement them. It's really good exercise to understand how it works. Okay, so what does the integrator do here? Again, it takes a state that I don't care about. It takes an element in the downstream, and then it applies the function to the element, right? The mapping function, as you would expect. It applies the mapping function, and then it passes that element downstream. What that was created from that. And again, I just return the gatherer of integrator there. So everything that just creates a one-to-one relationship between input and output would look like this, which arguably there can't be any other than map really in a one. Probably not, because what else are you going to do? Like the function can already cover all cases. So again, this is more like a demonstration to start to understand how the structure is. Now we can do something a little bit more interesting. There are 3 building blocks on top of that. And they all deal with state, because as we will see, most of the examples that you can come up with involve state. So state means, as you would think, you're keeping some state through the processing of the pipeline. You get an element, you push the element downstream, but in between, you change something about the state, because that's what you need to do for your operation. We'll see examples in a second. So these are all involved with the state. The first one is the initializer. Create a new empty state, or empty. Just create a state object so I can start using it. And you remember that the integrator always got that state object, right? Then we have a finisher that runs at the end. So when the stream pipeline is all done, the finisher runs and accepts the state, and the downstream combines them, and then you can emit more elements. And this part is really critical. This is why some hacky ways to create something like a window function in the past didn't actually work. If you're willing to create state externally to the stream pipeline, which is already really fishy, you could try to do things like grouping. But the issue was that it was really hard to get the last elements to show up. Because once the last element is processed, you don't know it's the last one, and you don't know that there will be no others. And the finisher fixes this by being called when every element has been passed, then your gatherer's finisher will be called. And if you want to do this in a parallel stream, you need to combine the states of different streams. But we're not going to look into that. Most examples I could come up with really only work for sequential streams, or actually all the examples, I think. And I think that's very common. So let's not look into combiners. Let's instead create something like fixed size groups. So I have input, I have AC, FBS, and I want to get just groups 2 should give me groups of 2, but also the last element. I still want that one. So what do we need for that? We need an initializer to create a list for the group that is empty. Then we need an integrator that takes the elements, puts them into the list, and when it's full, it emits them. And then the finisher has to emit the incomplete group. Okay, so the initializer is super simple. Give me that's the syntax. It's just a supplier of whatever I want to use as a state. Apparently, I want to use list of t as a state, and array list new is a supplier of a list of t. So that's straightforward. The integrator gets the list, which is the state, the element, the downstream, adds the element to the list, and then it checks what else needs to be done. When the list is not yet full, we're doing nothing, but we need to return true to signal to the stage before us, the stream pipeline stage before us, give us more elements. This is what this true means. This true means we're still not done. Because you know that there's like a find first, for example, that cuts the stream execution short. This lazy, these kind of operations are transported through this back signaling here, where we say, okay, we got an element, we still want more elements if there any more elements are available. Otherwise, so now when the list is full, we create an immutable copy, clear the mutable one, and then we push the immutable copy downstream. If you do anything like this, please, 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 if you deal with collections, or even if it's other data types, please push immutable stuff downstairs, make really sure, downstream, make really sure that you don't have like a reference to something mutable that you pass through the stream. That way lies madness. That's how I try to fix try getting my grouping working without this functionality, and it's really terrible. But the important part is the downstream might now say, oh, I'm done. There was a find first here, and we're ready. So we're done now because we got our first element. And then this might return false, and that's why I return this here, so that then the stream pipeline knows to stop processing here. Okay, that's all good, right? That's pretty straightforward. The finisher then is also very simple. Just create a copy of the list and push it downstream, no matter how many elements are in there. I'm just now, when I'm saying this, realizing I should probably check whether the list is empty. Because if it's empty, because I think this is a bug, actually. So if we just happened to end on a full list, we now have an empty list, and then I'm creating a copy of the empty list and pushing it downstream. I'm pretty sure there should be an if list is empty check here. Okay, but again, I think that's pretty straightforward. And then if you create all those three things here, you would call gatherer of sequential. It says of sequential because it doesn't have a combiner. So you're signaling here, my gatherer will not be able to do parallel processing and as you see here, you know why, right? Like making groups of two is really weird if you have a parallel stream going on. Although it is possible, like it's not like it's impossible. But then you need to combine several states from different executions, and then you need to make sure, okay, so now this has one element, this is one element, so together I emit one more element. So yeah, but it's possible, but I think mostly makes more sense like this. And this is how we would use it. Just say groups two. Again, this is probably a static import of a method mygatherers.group, which is this one, right? And then, yeah, that's what you would get there. So there's a jab about this, as always. Victor Klang gave a talk here, maybe even last year, teaching old streams new tricks. Victor is not talking about gatherers this year, as far as I know, but he is here at the conference. So if you have questions about that, feel free to find him. By the way, all the people I mentioned earlier that work on OpenJDK, that work on Oracle's Java, all the people I mentioned here, there are people who work on OpenJDK that are not part of Oracle's Java Platform Group. But the people that I mentioned here, they work on Java Platform Group, and they're all here. Some of them are here at the conference, and you can find them at the Oracle booth throughout the days here. So if you have specific questions about this that maybe you didn't want to ask me, or you feel like want to ask them personally, try to find them there and talk to them there. Victor will be happy to talk about stream gatherers. I think he did a really, really cool thing here. I've already created a bunch of those. Every project I now code on, sooner or later I realize, oh yeah, that operation actually makes sense to pull that out. And it gives you a really good framework to think through this use case in a little bit more abstract way, but it's still not too abstract. You don't add a lot of extra work for this abstraction, right? We all kind of don't want to abstract too early, or often we don't want to abstract too early because we feel like that's just extra work that's going to hurt you later when it turns out it was the wrong abstraction. But this abstraction for most use cases is not really complicated. So something like groups, for example, here seems really reusable. It's kind of straightforward to write. Also something like take while including. I'm not using each gatherer instance a lot throughout the project. Often it's just once or twice. But it's so nice to slowly build a little bit of a library that does these things. Right, and then we have 2 more videos on that topic. You have questions about stream gatherers? There's one up there, I think. The question was, can you use multiple gatherers in one stream? Yes. I should maybe have mentioned that. Collectors are a terminal operation, and you can only have one terminal operation, but gatherers are an intermediate operation. So you can have several gather calls immediately, sequential, or with something in between. Yep. So the question was, well, if you can have several gatherers, could they share a state? I mean, nobody's going to stop you from it. So if this method call here does not return a new, but returns an instance that exists somewhere, but like I doubt that that's going to end well. But I would be sure if you do that, please let me know about it. I want to see that because you can pretty surely build some cool stuff with that. But again, like it sounds fishy, so I'm like, generally speaking, don't. But yeah, it should be possible. Yes. Also notice that the reason why you give a supplier here and you don't just give the element, you could just, why does it supplier? Why is it not just give me an instance? The reason for that is that if you have parallel streams, this supplier gets called more than once, right? Actually, you get no guarantee when this is really called. And also here, do you get always the same instance of the list? I mean, kind of, because nobody knows, there's no copy being made, so why would the Stream API know how that it's a list and could copy it? But still, you get no guarantees. So the reason why this is all written this functional way is so that the Stream API is in charge of what gets called. That's why you always return functions, so you can call the same thing several times, and for those reasons. So that means that you can make certain assumptions, but then you're moving outside of what is part of the specification of the Stream API, and that might mean it might behave in unpredictable ways, or might behave differently under parallelism, or might even technically behave differently on different JDK versions or operating systems, however unlikely that is for something like the Stream API. But yeah, leaving the well-specified ground can always get you into trouble. But again, sounds like a cool experiment though, so. Good. More? Otherwise, we go to the last topic, the class file API. Yo, sorry, yes? Because the question is, when the downstream says, I'm done, will the finisher be called? And I do not know the answer. That's a good one. I don't know. And so the downstream is not, like, for example, when I wrote this initially, when I wrote this, when I experimented with this initially, I actually didn't track the Boolean that I got from the downstream immediately. And so I didn't always return the result. Sometimes I just returned true. And my understanding based on those experiments is that if I ignore what the downstream tells me, it doesn't make the stream misbehave. It just makes the stream do more work than it's supposed to. So you can definitely still push to downstream after it says false. It's just not going to do anything. And that makes me think that the finisher is not called. But I'm not sure, because because what would you do in a finisher? You would probably have to push something downstream, right? There's not really something else that you could reasonably do. And since that's downstream, will definitely ignore the result. I would guess the answer is no. But it's a very good experiment. If you're still around after the talk, we can just try it here right away. I want to find out too. Okay, class file API. We talked a little bit about bytecode already, very superficially. Let's go a little bit more details. Bytecode is the instruction set for the JVM. The JVM is a virtual machine in the sense that, it works kind of like a real machine, but it's virtual. But it means like it has inputs and it has states, and it just gets fed commands, and based on that it behaves. Now in practice, for every code that is non-trivial, that is used in your program a bunch of times, you get the just-in-time compiler compiling that to machine code and blah blah. So the machine part doesn't really happen that much. But that's the semantics, right? That's everything that the JIT does is just an optimization. In this interpreted mode where you really have the machine doing these steps, it just reads these commands, right? You have these bytecode instructions for creating objects and arrays, variable values, to invoke methods, plus and minus and all that. That's all bytecode instructions. And the simplest possible lifecycle for this is you write your Java code, then you run javac and you get the bytecode. Those are the .class files. They're stored on disk. Maybe you put them into a jar or not. Eventually, they will be loaded by the class loader, and the class loader will then, once it loads it, needs to parse the bytecode and needs to verify it. It needs to make sure that the class file does actually adhere to the JVM specification. So there's the Java language specification, which is what Angelos was referring to earlier when he said chapter 5. He's talking about the chapter 5 of the Java language specification. There's also a JVM specification. And that, so the class will make sure that the bytecode follows that, so it doesn't blow up the virtual machine, and then the machine will execute it. But in real life, much more is going on. So for example, your frameworks might generate bytecode for you at build time. As I said already before, the just-in-time compiler, or for example, Graal native image, might turn your bytecode into machine code. Something like class data sharing, which now starts being called, thanks to Project Leiden, the AOT cache, prefetches stuff from the bytecode and already does some of the parsing and the verification. JDEPs, but also external tools like Spotbugs, may operate on the bytecode to evaluate it, to glean certain insights, for example, give you a dependency tree or see whether we use certain language patterns that are known to be buggy, or patterns that are known to cause issues. That's what Spotbugs does. And as I mentioned earlier, agents and libraries might manipulate bytecode, right? They might inject log messages, they might inject metric calls, they might use proxies to track state changes. A lot is going on with the bytecode, and I tried to capture this in this handy diagram where this here is the bytecode, and then you have the agents and libraries working on that directly, just like the JVM does. But before that, it's just class files, and you have a bunch of tools working on that as well. So what I'm trying to transport here is, yes, bytecode technically is just this simple intermediate artifact after compilation before execution, but it's not that simple. There's actually a lot of tools working and operating on it. Either becoming really, really boring, or like I didn't mention, no, it's 12:15. Okay. Are we good still? Yeah? Okay. Okay, so libraries often don't manipulate. So there's a lot of bytecode manipulation going on, is what I'm saying. Like a lot of these things read or write bytecode. And that's not a fun task. So they don't usually write that themselves. They usually use some of a few tools. There exist a bunch of them, and the big player of them at the bottom of this inverted pyramid is often, not always, often ASM or ASM. So ByteBuddy, CGLib use that, for example, and the JVM itself uses it, sorry, the JDK itself uses it as well. So yeah, ASM is really essential here and does a lot of the bytecode manipulation. The author of that is Rémi Forat. He's here as well. He's not one of my colleagues, although he's like very smart cookie, working on a lot of things in the OpenJDK space. He's maintaining ASM, and as my understanding is, he's also kind of happy that maybe he can stop maintaining it at some point in the future, because there are a few issues here with this this process and with the way that this works. The bytecode has a level, because every new Java version can add new functionalities to the bytecode. You cannot expect JDK 11 to run something that source code that was generated, bytecode that was generated for JDK for the JVM of version 21. And the way this is checked is there's just a bytecode, there's just a level embedded in the class at the beginning that says, hey, I'm bytecode level 65. Not sure how they got to 65, which is 21 Java versions, but I'm sure there's a reason. So Java 21 says bytecode level generates, if you compile for 21, you generate bytecode level 65. And if a tool doesn't know 65 yet, because let's say ASM was written, the ASM version that you used was written for Java 17, it sees, oh, the bytecode level is higher. And now it's two choices. One of them is, and that's what it does, to say I cannot work with this. Right? This is too advanced. There might be things that I don't know. This doesn't work. I think potentially or hypothetically it could just cross its fingers and just, let's see where we go by trying. But it doesn't do that for a good reason. The problem with this is this can block updates. So let's say you compile your code with Java 25, which will be level 69. Then, did somebody say nice? Anyway, so you have your web app. You use Java 25. Now yellow is what you need to update. You update it to 25. You wanted to update to 25. That's what you did. And now you're generating bytecode level 69. And now ASM says, yeah, I don't know that. I was built for 65. And so, okay, so let's update ASM so that it also can read 69. So that's why that one is yellow. But in this hypothetical Spring Boot app, Spring Boot actually shades ASM. So you can't just update the dependency. So now you have to update Spring Boot. And that means you have to update all your dependencies. And now you're like, wait, I just wanted to generate newer Java code. Why do I have to update like all my dependencies for this? This is a bit ridiculous. And this is one of the core reasons why the advice I've been giving for years is to be prepared for a Java update, for a JDK update, keep all your dependencies up to date. And keeping dependencies up to date is good advice in general, but still there's a specific connection here. And this is one big reason for that connection. One big reason is that the bytecode manipulation really only works when the bytecode you generate and your dependencies bytecode manipulation tool can work on the same version. And we would like to move away from this, right? It would be kind of nice if you could just update the JDK version without having to update your dependency tree. Okay, that's what I just said. That's why this, where this advice came from. So I want to move past that. And the idea behind the class file API is that it will be an API that is embedded in the JDK. So the JDK will come with its own class file API. So that will always be up to date necessarily, right? If you create it on Java 21, it knows Java 21 bytecode, but if you generate for 25, it knows JDK 25 bytecode because it's the same, it's a new version of that library in the JDK. So it's stable, it's a stable API, and it's always up to date. And then when the JDK is updated, what can happen is that your dependency, which uses the class file API, now the class file API now says, oh, I found this bytecode. And then your dependency might think, wait, I was written for Java 21, I don't know what that bytecode does, but then it can decide what it can do, because very, very often it doesn't matter. If you want to build a dependency tree from the bytecode, you don't care about 95% of it. You just care about very specific portions of it. And if there's a change elsewhere, you just wouldn't care. And the class file API is written in a way that all the things that you or your dependency don't care about are easily ignored. So only the things that you do care about you will be exposed to, and when in those things changes happen, then yes, you might still have to update your dependency, right? If the bytecode manipulation tool you're using deals with a certain kind of bytecode operations, and those got a new one or changed otherwise, then yeah, you want your dependency to stop working at that point and say, like, I encountered something I didn't know. But that's not the common case. In very many cases, those changes can just flow through. And then you would get this. So you update Java 25 from 21 to 25. The class file API uses the right version. ASM is out of the picture because Spring Boot can just use this one. Again, it's an example, right? I'm not saying Spring Boot should do exactly this. Maybe they have a layer in between. I'm just saying this is like the simplified example I made. And because this is up to date, assuming that this does not use anything that really doesn't work with the new bytecode level, everything else just works. And you don't need to update the whole tree. And that's the big impact of this for the ecosystem. That's why I'm not describing how the class file API really works. I've written some code with it that reads bytecode, but it's rare, right? Most of us don't do that on a daily basis. The importance of this for us is not we're going to use this API, unlike stream gatherers, which I think many of us will use. We won't use this directly. We will benefit from this indirectly, because once this is finalized, and then Spring Boot baselines against a JDK version that includes it, and then phases out ASM. So you can see there's a lot of when this, then that happens. So that could take a while, a couple of years, right? I would not expect this to be done before 2030, I guess. Which is kind of terrifying to say, but it's realistic, right? Like none of these things happen quickly, but it's important that they do happen. It's important that the right decisions are made now so that these things can flush out, which also, by the way, applies to all these deprecations. This will take a while until it's gone, but that doesn't mean that it's not still a good time to start now. Okay. The JEP, as always, and then also I made a video about that at the bottom, but I already gave you all of those information, so that's really just a recap. But Brian Getz gave a video at JVMLS, gave a talk at JVMLS last year about the class file API, and I just generally, like, I'm such a fanboy. I just generally recommend listening to what Brian gives a talk. I always feel like I get like 20 IQ points while I'm listening. I feel like I lose them soon after. But as much as I can retain, it really helps. Like, he talks about API design and why this API design was picked and how we went through this. And so yeah, I think just the talk is really interesting, even if you don't care about the class file API, because funnily enough, he also doesn't go into much detail about how it's being used. He explains a lot about the design and the reasoning there. Okay. That was it. Just a few slides for a close. So Java 22 and 23 in a few slides. This are all the final features you can use now, with links to all good explanations. These are new previews that happened in 23, primitive patterns and module imports. This is all the previews that continued. We skipped past structure concurrency and scope values because there's a high chance that they see changes in 24, so I didn't want to present to you a preview that might already change. We don't know that yet. Everything else on this list, oh, and I didn't go through the vector API, it's still the same. So that's that. And so Java 21 was really kind of explosive, right? It came with virtual threads, it came with all the basic building blocks for pattern matching. It was really big. 22 and 23 are not that big, but they do what needs to be done. They slowly continues Java's evolution in all kinds of spaces, from the runtime, in tooling, performance, language, APIs. Went through all of those things today, and you see all of those things are getting better. You get JDK 23 now, even if you're not the one person who might use it in production, you can still use it for your experiments locally, try to get to know it, so you're prepared when when the next version with LTS comes out and you adopt that. And with all that out of the way, I want to thank you very much for your attention, for staying here for like almost 3 hours. If you have more questions, you can come down here now. You can meet me at the booth. I'll be here all week. You can follow me online. I'm NipaFX everywhere. If you need to have a free weekend and want a headache, you can read about the module system. Go to insight.java and dev.java to follow Java's development. Follow us on YouTube, social medias, all of that good thing. Have a good lunch. I'll see you around.